Hello, welcome to another stream. How about that? How about that? Bet you didn't expect that shit to happen yet again. It happens almost every day. And you still don't expect it. Hello, Mr. Botka. Hello, Nitrix Life Out 9. I Good Duke. Copper Casted. Neutral Second. Rotten Chauncey. Yet Anasov. Sodding TOS. Hello, hello. Nerdy Between. Neutral Second. Already called you out. Ivan Ho, hello, haven't seen you in a while. Yet Anasov, Nutrix Live, Dear Pandas, hello, hello. Cerimon, welcome, welcome, welcome. Art 6969, hello, hello, hello. So today is a Tuesday, and that means today we continue to develop our virtual machine. That's right, we're developing it. We're developing it today. So, and what this virtual machine is all about? This is not your regular this is not your regular virtual machine, like VirtualBox or anything like that. It's more of like a virtual machine for a language, like JVM, for example. But our virtual machine is better than the JVM because it's faster, at least. Yet, we'll see. Maybe over time it will become slower. So we're developing it for our another project, which is a Lisp programming language. So once this virtual machine is done, we're gonna try to integrate it with our Lisp language. Yeah, the schedule is scuffed. I'm really sorry. I just came from the outside, just came back home, and I wasn't able to quickly update the schedule and stuff like that. So I'm gonna do that after the stream. So yeah, today we're gonna just continue developing this virtual machine. You can check out the source code of this thing, and let's just jump into it. But before we jump into it, I need to make a cup of tea. So I turned on my kettle right before the start of the stream, and yeah, I didn't have time to actually pour myself some hot water to make a cup of tea. So I'm gonna go to the kitchen. Don't go anywhere, or as you know, permaban. The usual. The usual. What? Where is the music? Can I sit into it? I'm still sleeping. Sure. I guess. What are you talking about exactly? Sit into what? All right. So let's start doing a software development. Okay. TeamViews. BM. So we're still on some sort of a branch. Let me fetch the latest stuff. How did you hone your craft and get to the point you're currently at? I shaved my head. Let's jump into it. Alright, sure. Yes, sure. I see. So yeah, to become as good as I am at programming, you have to shave your head. There's no other choice. Yes. Sorry. I'm just joking, by the way. You don't have to do that. So seems good. I think we have a bunch of branches that we need to delete, 32, 34, and yeah, all of them are merged. How about that? So let's go. Let's open the project and take a look at some of the issues we have. So we can go through the virtual machine, through the main parts of the virtual machine. We already did that on previous streams, but we can do that one more time. So it consists of a library, which is a header-only library. The whole virtual machine is contained within a single file. You can add it to your project and have this virtual machine in your project for some reason. Not really sure why would you have that, but you can do that if you want to, of course. And we have 3 executables. 3 very important executables: Bosom, BME, and Debusm. So Bosom basically allows you to take a source code in assembly written for the virtual machine. It looks like this. So this is an assembly for our virtual machine, and it turns it into a binary file that then can be fed into BME, which will emulate the virtual machine and execute the compiled program, or rather translate it, because we don't really do any compilation. We're just translating assembly code into the bytecode. And for the convenience, we also have debusm, which disassembles the translated bytecode back into assembly. So that's pretty much it. That's pretty much it. So we have a library that you can integrate into the thing, and assembly and disassembly. Show FFI. Okay, so I can show you FFI. It's actually pretty dumb right now. It's like a rough outline of the FFI, but this is basically what you can do. So we have a special instruction called native, right? So, and what it accepts an index of a native function within the virtual machine, right? So, and a native function usually looks like this. So we can take a look at BME. It has a bunch of such functions. For example, yeah, this is one of the native functions. So the signature of native function is that it accepts a virtual machine and it returns a possible error. And essentially, when you execute that function, it mutates the state of this virtual machine. So you have to hardcode it. Right now, yes. Right now, yes. We have an issue for actually implementing hot loading of these functions from DLLs, but we haven't implemented that yet because it's not that important for now. Because the usual use case is that it's going to be a library that you embed into your project, and since you embed it into your project, you can actually hardcode these functions. But maybe later we can implement like hot loading them from some sort of DLL or something like that. We'll see how it goes. Imagine being able to compile BM to a native code. We have an issue for that as well. All right. So, but we're not gonna jump into all of these complicated things yet, because we need to prepare our code base, sort of massage the code base. Otherwise, it won't be able to handle these huge, juicy features that we're gonna impose upon it. What the fuck am I talking about? I need to pour myself a cup of tea, and believe it or not, I forgot to bring a mug, so I'll have to go to the kitchen yet again. And when will you compile Lisp to VM? When VM is ready for it. When VM is ready for it. Does it make sense? So I'm gonna go back to the kitchen because I need to bring a mug where I can pour the juicy liquid that I can drink off of. Okay. I just gotta go. I just gotta go. Hello. Hello, Harrison. Welcome to the streamers. Hello, Leviathanus. Leviathanus. I like your nickname actually. It's a pretty cool nickname. So let's pour a cup of tea. It's not pourable because I didn't align the holes. Hello, Aaron6969. Welcome. Hello. And one more drop. And we have a cup of tea. Isn't that amazing? Isn't that amazing? It's absolutely flippin' amazing. So let's start with some of the issues that I haven't addressed for quite some time. For example, I wanted to implement some sort of a preprocessor for our assembly. I see project in C, I'm here. Seriously, VM projects are so fun. They are in fact fun. I see PC. I see pee when I pee. Ah, I'm sorry. Okay. So essentially, we want to, yeah, yes, we have a counter for that. Of course, we have a counter for that shit. We have a counter for any stupid shit that I say, sure. Yes, so I want to have a preprocessor like similar to CPP. A CPP is this thing, it's not C++, it's a C preprocessor, right? We don't even have a man page for it because nobody knows about it. But yeah, so this is how it looks like. So not everybody knows that, but the C preprocessor is sort of like a decoupled component from the C compiler. For some fucking reason. Probably for historical reasons, because it's a very old language. It was developed in 1970. So, yes, it's 50 years old. Imagine programming in a 50 years old language. Holy shit. Oh my god. And people still do that. People still do that. There's a shit ton of software that is used every day in production. That is written in that old ass language, and it works really well. It works really well. I'm not gonna lie. GNU is decoupled too, probably for the same reason. Yeah. So maybe they were trying to simplify the things. So yeah, you have a language, and then for compile time stuff, you preprocess it. It's just kind of we need to be in those times. We need to go 50 years back to understand the reasoning behind all of these interesting decisions. So-called Unix way. Yeah, I guess you can explain any weirdness of Unix with the Unix way. C++ was also compiled to C and in the early stages. Yes, it was. I think it was even called C with classes, if I'm not mistaken. C with classes. We are on Wonderman PC like 50 years ago. Yes, exactly. Okay, and yeah, so my idea is that can we just use the C preprocessor? Like, can I define? So I know that this thing is printf. It's actually, I think it's a printf. It's not really printf, but print i64. I think that's the first one, if I'm not mistaken. So Bosom. It's not really Bosom. It's supposed to be BMU, and we have this list. So 4 is U64. Yeah, that's right. That's right. So U64, I can define something like that, and I can say that it's 4, and then instead of doing 4, I can do something like print U64. There we go. So can we have something like that? That would be actually pretty cool. And then we can actually move all of these definitions to a separate header. Oh my god, I have so many ideas, chat. Look at that shit. So we're gonna call it stdlib, and it's gonna be stdlib h, not h, but bosom, right? So this is what we're gonna have here, and I'm gonna do the following thing. I'm gonna replace all of this shit with define. Like that, right? And then so can we do something like this? That's right. Yeah. Boom. There we go. Would you look at that? Aid sleep. Maybe. We'll need to think about the specific naming here. So yeah, we can have definitions for these things here. Alright, and then in the fibs bosom, instead of doing that, I can just include something like stdlib bosom, right? And there we go, I can have these native functions here. Isn't that amazing? But the problem is, this shit is not gonna work. Guess why this shit is not gonna work? Guess. Because we're using hashes as the comments. And I think that is gonna fuck up the C preprocessor if we try to C preprocess this thing. What do you guys think? I think it's gonna fuck it up. I think it's gonna fuck it up. So, alright, so let's actually try to fuck it up. How do you use a C preprocessor? Does anyone know? So do I just do CPP and I provide BASM? Zozin, C compiler in Lisp when? Today. By the way, Cozy White Bear, hello, really glad to see you. Boom. And we've got mail. So what do we have? Invalid preprocessor directive end. There we go. It's an invalid preprocessor directive. So we can't do that. We just can't do that. I guess... I don't know. Won't fix? No! No won't fixes, okay? Because we are God Cougars, we can fucking fix that. And the fix for this entire thing is gonna be change the style of comments. It's that fucking easy. Just change the style of comments. How about that? Isn't that amazing? I think it's gonna be amazing. And what's... Okay, so let's actually open the can of worms. What's gonna be the style of comments for BASM? Go! Where are all of the bike shaders? I don't see enough bike shading in the chat. No comments. That's a good idea, actually. Create a vote. I don't know how to create a vote. To be fair, personally, so far I want to use like a semicolon. Should be self-explanatory. That's a good idea. It's a nice comment symbol. Thank you. This is a volume. You're already spending too much time on assembly stuff. Just make eBisp emit bytecode. No, the virtual machine is not ready yet. We're gonna work on spitting out eBisp, making eBisp spit out bytecode when the bytecode is ready. Bytecode is not even stabilized yet. So the actual values behind these things are constantly changing. Right, and on top of that, the reason why I spend so much time on assembly is because I use assembly to test virtual machine. This assembly is actually a very crucial tool in testing and ensuring the virtual machine actually works correctly. Without it, like, it's kind of useless. Alright, so I think we're gonna go with semicolon because I personally want it. A couple of people said that they think it's a good idea, and also there is like some sort of like convention in assemblies that all of the assemblies use semicolons. Alright, so that's gonna be the first step in actually making the preprocessor work, and I'm actually thinking like maybe we can even create our own preprocessor that is better, but it feels like such a derail from what we're doing. So I don't think I'm gonna do that. So, but like a custom preprocessor would be kind of good. Derail on top of derail. Fruit sorting away. Get the fucking damn it. Like I implemented the whole operating system for virtual machine. Because I needed to develop. So I needed to develop virtual machines somewhere. So I developed an operating system in which I can develop my virtual machine. You know, so because just, why not? All right. So what's the issue number? But the usage of the C preprocessor is not going to be final. I don't particularly like it, but I do need feature that preprocessor actually enables, like defining constant compile time constants, including files, conditional compilation. All of that is super useful, and I really want to have it. So that's why I'm sort of making like a quick hack to introduce the preprocessor. Okay, so this is the branch we're working on. Okay, so I'm gonna quickly fib BASM. If only we had macros like in Lisp. We could try to make something like that, but yeah. Alright, let's continue. So let's create a branch. It's gonna be 8, and so let's go. In the BM itself, where do we have comments? Oh, there we go. So this is how we handle the comments, believe it or not. This is how we handle the comments. Yeah. So what I'm thinking is that I need to introduce some sort of a constant, bosom comment symbol, and it's gonna be just this, right? So in all of the places where we are referring to the symbol, we're gonna replace it. So there's at least 2 of the places. So the first one is needed for the line that starts with the comment, and the second one is needed for the lines that has the comment at the end of the line. So it's kind of important here. So it's gonna be bosom comment symbol, and another one is gonna be bosom. It's not a push label, it's actually comment symbol. Cool. So, and I can now try to recompile all of that, right? Make -b. So now I want to try to simply replace this entire thing. We're going to be replacing it with just that, and it will automatically work. You see how easy it is? If you structure your program correctly, you can just replace one thing, and there you go. The style of comments has been changed completely. We can try to build all of the examples and see how miserably they fail. Something like examples, right? And okay. So what does it say? It says that this is an unknown instruction. So that means we need to do the following thing. I'm going to query replace hash with semicolon, and there we go. Everything works okay. Good. Next one, the same query replace. Another one. Another one. Oh, this one is interesting. Okay, okay. So our makefile automatically builds everything with the extension bosom, even the standard library. So the headers should be actually called something differently. So bosom is the main thing, and we need the headers. So hasm, probably bad idea, but yeah. So PyBosom, let's actually replace this stuff. Oh shit, oh shit, oh fuck. This is not what I meant. This is not what I meant, so I actually want it like that. It's kind of dangerous, not gonna lie. Alright, so what's gonna be the next one? And everything, as you can see, compiles here perfectly. So we changed the style of the comments. Alrighty. So the 8, change the style of the comments. To this, and I'm gonna push that right into the repo. Cheers, by the way. Living on the wage query replace all. I mean, I don't really have that much code to actually worry about this kind of stuff. So, yep. Now, we can try to do some sort of a preprocessing first. So, I'm gonna go to examples fib bosom, and in here we're going to be including stdlib bosom, right? And in native here we're going to have print u64 because it's 8. And let's try to preprocess this file and see if it's gonna spit out something actually useful. So it's gonna be cpp bosom, and it couldn't find this file because, well, it's not called like that. And yeah, there we go. So this was the result of the preprocessing. So print u64 was replaced with just 4. And this is actually kind of convenient. I kind of like it. But the question is, there's also this header that is always printed by the C preprocessor, and I remember that somebody in my chat at some point said that you need to have a special flag to suppress that header, right? To suppress that header. How would you suppress that header? I don't remember. Does anyone remember? No canonical. I think it's a no canonical prefixes. Is it? So let's actually try. No. Oh, it's minus p. Okay, okay. So let's give it a try. It's gonna be minus p, and there we go. Yeah, that's actually cool. Yep. So that's exactly what I wanted, I suppose. And it also removes, like, I think the original file contained spaces here, and it removed these spaces. Which is kind of dangerous if the spaces have some sort of a meaning, but in our case I think it's okay. Alright, so now compilation of these examples becomes a little bit more complicated, right? It becomes a little bit more complicated because now you have to call the preprocessor yourself, and it's not very convenient. I really don't like that you have to call the preprocessor. This is especially buggy if you have C-style comments. And let's say you can't solve things with P. Yeah. Is it really worth it? Is it really worth it? I don't really like that we have to use a separate tool for all of that, but we do really need all of this. We do really need all of this. We can try to make the Bosom call, Bosom call this thing for us. But again, that is not very cross-platform, unless we're using something like system, right? But yeah. Okay. So hopefully at some point I will be able to get rid of that preprocessor. So I need to understand what I'm using preprocessor for. What I'm using PP for. Compile time constants. Right, compile time constants. Like print U64 and etc. Right? So another thing I'm using it for, including files and conditional compilation. Right. So yeah, if I can. So I don't think I'm using it for anything else, and I don't think it is usable for anything else, pretty much. Right. If I can find replacement for these three cases, I will be able to get rid of the preprocessor. Just use them for how does that fix the problem of having a separate tool? It's literally replacing one tool with another one. It doesn't fix anything. Alright. Okay. So this is important to keep in mind. But before we go into that, so how we're doing all of this? Bosom. Yeah, so essentially, where's the examples? Am I crazy? Wait. Wait, is that like a... Oh, I didn't notice that. I was looking for these GNU things, so it's a different way of doing this stuff, I suppose? Interesting. Oh no, does it introduce the same problem? I should have looked into your pull request a little bit deeper. It introduces the same problem that everyone, literally everyone, overlooks every time. Oh my god, okay. So I need to clean everything, but okay, I'm gonna just remove that for now. Okay. Git clean FDX. I wonder if I can fix that by doing something like a Bosom. I cannot fix that. It's literally unfixable. So you literally have to do first this thing, And then you have to do this thing. Only then it's gonna work. Yes, classic. So with the previous code, it worked. It worked because it was one of the dependencies of this thing. So what's funny, the interesting thing, Zhiyang was also submitting the changes to the pattern, and he also overlooked that problem. So yeah, you cannot just build a very specific example when nothing is built yet, because the bosom is not part of this thing. Okay, so I'll have to fix that at some point somehow. I don't know how though, but we'll see. Maybe I will have to rewrite, like, maybe I have to get rid of the make file, because there's too many problems with make files. Let's actually replace it with you know, build.sh, right? We already have build msvc. Let's just fucking have a build.sh, because every time I'm trying to do something with make files, it's either like something is not supported on that operating system, something blah 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 blah. Like, why? Let's actually build everything from scratch all the time. Why not? Furthermore, like, our program is so small that it's gonna be super fast, right? It's gonna be simply super fast. And I wonder, like, I think we don't need to set CC. So if I take a look at the CC, it's not set to anything, but maybe we'll see what we have to set it to. So let's always build everything, always. How about that? So, and this way we don't have to ever worry about, you know, POSIX, not POSIX way. Just build everything always. And then when we're building examples, what we're essentially doing is, well, yeah, we'll have to do it like this, I suppose. Not sure if it's gonna work. Begin ASH. And it has to be something like that. Oh shit. Okay. You know what? I think I can replace this thing with nothing. Yeah. I'm gonna replace this thing with nothing. And this way we're gonna have a special file. So now file f in what? So I think we're gonna do it like that. We're gonna do it like that. Maybe I'm gonna call it example, a single example. And since we already built everything, and by the way, we also need to do set -x, because, and also not -x but -e, so essentially if something fails, it won't try to continue and build the rest of the stuff. What's up, Fayethex? Welcome to the stream. Welcome, welcome, welcome. So bosom is going to be example dot bosom and example.bm, right? Something like this. And will that work on FreeBSD? Will this script work on FreeBSD? Probably, maybe, I don't know. We're about to find out. We're about to find out. So let me try. Does it build W all not found? W all not found, and this is because, yeah, we have to put something like this. So I'm gonna go to the compilation. So what I see here is that CC is not set to anything, so we can set it to GCC first. Like, I think there was a way to check whether CC is already set, and if it's not set, set it to something else. There was like a special syntax, but it could be bash. It could be bash, for what I know. All right. So to be fair, I also wanna do XC. Is cross-platform. Oh, okay. So I see what you mean. User bin CC. And we can set it like this. There we go. Looks good to me. So, and it doesn't even take that much time to rebuild everything. Look, look, look. Our project is so small. This is how much time it takes, half of a second. Like, rebuild everything and rebuild all of the examples. And to be fair, this is exactly what I do anyway, so. Yeah. What do you guys think? Is that a good idea? Unless it starts to become really big, but I don't know if it's gonna be that big to worry about this kind of stuff. I don't think it's gonna be that big. All right. So it's actually kind of cool. Like at any point, like you just do this and it just rebuilds everything. Okay, so we need to remove makefile, and yeah, we already have a build MSVC, build that. Let's update this stuff, and it's gonna be build sh. Not under the root though, not under the root. You have to do that like this. You can put it like this, or build MSVC bat if you are on Windows, right? So if you are on Windows, so I think it's a pretty good remark here, and then you can just execute one of the examples here. Just execute one of the examples. So this is not enough. We also need to update the CI build, right? So we do make all, and then we also build examples. Oh, that's interesting. Assemble examples. I don't think now we even need to do that, because I can just do build sh, right, and just remove this part. So I don't think it's needed. Oh, and this is what I was talking about, like, right, CC. And depending on CC, like, it has to be different. Look, so if I set CC to Clang, it will still use the this thing, right? So it doesn't use Clang anymore. What's the syntax to set it? I remember there was something like this, right? There was something like this, but I don't quite remember. Shall check if variable is not set and set it to I don't know how to say that. Like, I never know the... Well, this is not exactly what I meant here. I can use like the if conditions and stuff, but I don't think it's that convenient. There was some particular syntax, and you can never remember the name of it, and it's something super weird and ungoogleable. Like, trust me, it's always fucking like that. Does anyone know what I'm talking about? Does anyone know what I'm talking about? Parameters is something like similar to parameter expansion, but it's so bad. Why doesn't have a... Yeah, I remember using it at some point. Fuck, and it's drives me nuts. Bash default variable if... Yeah, something like that. Assigning... Oh, I think it's bash thing, but hopefully maybe a shell is supporting that. Yeah, kind of like this. If variable not set or null, use default. If variable not set or null, set it to... Okay. What's the difference? I don't understand. Or to assign default to variable at the same time. Second. Okay. So we need second here. So CC like this. Cool. And it worked. Alrighty, alright, it worked. Thank you very much. And if I don't set it, it is using the old one. Nice. Perfect. Perfect. Thank you, everyone. So, and I wonder if this will work on FreeBSD. So it works with just SH. So I assume that if it works with SH, it will work everywhere, right? So it's kind of like a way to sanity check this situation, right? Holy shit. It is POSIX. Okay, cool. This is actually a pretty cool POSIX thing. We're gonna use that. I think it's a POG6. God damn it, I'm sorry. POG6. Okay, again. Do we need anything else? Oh shit. It is official. POG6. Okay. Command line. Default. It didn't automatically jump to the right tag. Oh, this is because it was shell command language. Okay, I'm gonna just trust you that it's right. All right, let's continue. So this is gonna be that, and we also need to update 262. Okay. I trust you. I trust you. So we have that, and it's gonna be build sh, assemble examples. We don't need that. So hopefully on macOS it's also gonna work. So yeah, a single script to rule them all. Yesu, kawaii desu. Yesu. Alrighty. Do I need to do anything else, or we're gonna just have that all the time? Cool. So maybe I'm gonna start using these sh scripts like for all of my small projects, right? For small project, because for bigger projects with a lot of dependencies, using this kind of stuff is kind of like turns out to be cumbersome. All right. Replace makefile with build sh, and let's push that right into the repo. And I want to create a pull request just to see what's going to happen, just to see if the continuous integration actually calls this thing and it works everywhere correctly. Look, what are you talking about, Daniel 42? I don't understand what you're talking about. Excuse me. Alright, so this is going to be introduce support for C preprocessor, and it will probably close this thing, not 48 but just 8, and there we go. So far everything looks okay. We're building Linux and stuff like that. Let me take a look at some of them and see if it performs what it's supposed to perform. So build tool chain. It should be called slightly differently. It shouldn't be called tool chain. So query replace build tool chain, build everything. Build everything. So we just build everything. On Windows it's called something differently. It doesn't even build all and examples. Yeah, okay. Let's replace build everything, build all and examples, so it's more or less like consistent. Rename the CI steps, and I'm gonna push that right into the repo. Cool. So now we don't have any problems with incompatible makes and whatnot, right? We just have a simple shell script that builds everything. And if you want to clean it up, finally, you can just use git cleanup.dx and don't have to worry about that. How about that? Isn't that amazing? You can just do that, and then you can do build sh and rebuild everything from scratch. You can build clean, build clean, build clean. It's almost like I'm talking about a US president. So dumb, I'm sorry. Alright. What's next? We need to actually integrate that step of preprocessing of these all these files, right? So we need to take this thing and we need to do a cpp p. And we might as well actually What we're gonna redirect it to? We're gonna redirect it to example BASM PP, which stands for preprocessed, right? It stands for preprocessed, and then we take the PP version and turn it into BM, and then we can remove the PP version.
Yesu, I am Beko.
Thank you, Yatko, for 6 months of Twitch Prime subscription. Thank you, and welcome back to our epic C Preprocessor Club. That's right. Welcome. How does it feel to be a member of a C Preprocessor Club? You know, the CPP Club. Alright, so that's basically what we're doing here. Okay, good. And also, do we get to ignore the PP files? We need to ignore them as well. I'm ignoring PP files. Do we have a git ignore here? No, we don't, so it's actually global git ignore. Let's build everything. And yeah, so essentially, as you can see, we're like pre-processing everything as well. Which means that we can easily introduce all this stuff. So in the examples, do we have stdlib? I actually removed stdlib. Okay, so we'll have to do that one more time. Let me do it this way. So all of them are preprocessed and probably compiled. Natives, and it's gonna be, you know, just HASM, right? So I'm gonna go to BMEC, so here are all of the functions, and I'm gonna do the same thing yet again. Right, so it's gonna be define like this, and I'm gonna do it like that, and boom, boom, cool. And now in fib BASM, I should be, if I revert this thing, I think I need to, yeah, I need to revert it. I need to include natives HASM, and the natives here, I'm going to be printing U64. So now we can just use this kind of stuff. Furthermore, we can define something like N30, right? And then instead of doing this, I can just do N. Yep. So yeah, now I can have just this constant here lying around, pretty convenient. And I can control them from a single place, like all of the magic constants and stuff. And it seems to be working. I might as well actually try to not remove the preprocess file, because I think they're kind of useful. Let's not remove them, for now at least. Alright, so they are not removed, and in examples we can see the pp file, and pp file looks like this. So as you can see, the 30 was, you know, removed and stuff like that, native was replaced with that, and everything seems to be working correctly. So let's remove them again. Cool. Oh shit, so we'll have to introduce the preprocessing step to the Windows build as well. Luckily we do have a Windows build, so that means it's not gonna pass the compilation and everything. Looks like pretty easy to implement, I think. Should be pretty easy to implement, hopefully. Though I don't understand what the fuck is going on here. So Alright, so what I want you to do, Windows, I don't know, I think the approach of the preprocessor being a separate thing is like fundamentally like scuffed, because it just introduces a lot of complexity that is unnecessary. So let's take a look at some other stuff, like at how these examples work. If I try to do BM, right, it still does this thing, and then it still does this thing, and it still does this thing. Okay, so nothing is particularly broken, but yeah. Okay, so maybe we want to go through other places in our examples. And for example here, I definitely want to introduce natives, HASM, right? And what we're doing here, we're actually printing f64, right? So now I don't have to like worry about, you know, this kind of stuff. So what about this one? It's gonna be natives hasm, and this one I think is print i64, right? What's another one? Natives hasm. Oh, and this one is very interesting. So essentially what we're doing here, we're allocating memory. Then I'm printing the pointer, right? I'm printing the pointer, and then I'm freeing the pointer. So that's essentially what is going on here, and we don't have to think about like what this number means, right? So we have this header, and we can just work with all that. It's pretty convenient. I think it's pretty convenient. I wonder if I enable like NASM mod. It looks like shit. We definitely need like a special mod for our assembly. We definitely need it. So BASM. Do I have any natives? So native 2, if I remember correctly, native 2 is print f64. Print f64, and let me quickly include natives BASM. Natives BASM. All right. So what about this one? This one is already adapted. lerp. Lerp is not adapted yet, as far as I can see. So we need natives BASM. What are the native calls? Natives. So the only one I see is print f64. So that's the only thing we'll need here. That's the only thing that we'll need here. And the last one is spy native. This should be, yeah, the only. Oh, we have. Yeah, I remember this one. So this is something that could be used instead of the defines and stuff like that at some point. To be fair, chat, do you remember how I said that the only purposes we're using PP for, right? What do I use PP for? Is first compile time constants, right? Compile time constants, including files. Conditional compilation. All right. Compile time constants right now are primarily used for native functions. So we can solve this problem by having these kind of things, right? We can solve this problem by having these kind of things. We do include files, but we do include them only to include like the standard things. Yeah, let's actually think about that a little bit later. So, because it can get very complicated very, very quickly. All right, so let's include this thing. It's going to be natives, hasm, right? Native, and it's going to be print f64. Print f64. And I guess that's it. So these are all of the changes that I wanted to make, and let's try to rebuild everything. And it's actually hasm, and I really like how it tells me where exactly that happens. Apparently I made a lot of mistakes here. Okay, cool. Nice. And again, I want to execute bme I example fib bm. So it seems to be working. EBM, PyBM, everything seems to be working. All right. Introduce header with the standard native function definitions. All right, so let's push that right into the repo. Okay, so let's see if this will work. Oh shit, I don't even know how to call the preprocessor MSVC preprocessor. Fuck. I didn't even know how to call MSVC preprocessor, chat. It's so bad. Oof. And alright. Let me go to the kitchen and cry a little bit. Yeah. It's not a Windows problem. Guys. Windows is not a fundamental problem here. It's not a fundamental problem. The fundamental problem here is a separate tool that increases complexity, and as complexity increases, you know, the system starts to break. It becomes very fragile and breaks in all the places, and it just the fact that it breaks specifically on Windows is completely coincidental. So the thing that would be self-contained wouldn't break on Windows because it's self-contained, right? So it's a completely coincidental. Like, I'm not sure if you're being ironic or unironic, but I'm actually trying to be unironic here, and I'm trying to come up with a solution that would, you know, satisfy the needs in the future. Right. All right. Does anyone have any on-topic questions while I'm making a cup of tea? Because I need to make a cup of tea, because I'm about, after I make a cup of tea, I'm gonna try to get rid of the C preprocessor, because I only introduced the dependency on C preprocessor and we're starting to have problems all over the place. We made our build process more complicated than it's needed. It starts to break in some operating system where the compilers are kind of weird. You see, it's actually like a symptoms of we're doing something wrong. This thing has to be self-contained, and I have a couple of ideas on how to make it self-contained. So, does anyone have any on-topic questions while I'm making a cup of tea? So, the tea I'm drinking right now is Earl Grey, if anyone is interested. Do you put sugar in tea? No, I don't eat sugar. I mean, added sugar. It's kind of almost impossible to not eat sugar, right? Because a lot of, you know, for example, vegetables and fruits, they produce sugar naturally. I don't eat added sugar. On how many devices will this VM run? On as many as we manage to compile it on. What are you using the preprocessor for some intended purpose? I already mentioned what I'm using preprocessor for 2 times throughout the stream. Do you drink coffee? Usually yes, but right now I don't drink it. Right, I usually like just drink tea, like these days. All right. Does anyone have any other on-topic questions? Because I'm about to go to the kitchen. And once I go to the kitchen, you know what's gonna happen. You know what's gonna happen. It's not gonna be fun. It's not gonna be fun. Don't go anywhere, or I'll ban you. Permaban you. That's right. Keep watching the stream. Keep watching the stream. Yeah, I'm gonna Google the solution. Yo. I'm back. So here's an idea. We only need to be able to include files and define constants for at least functions and whatnot, right? So that's the only thing we need. And I think we can implement that without any preprocessor stuff. Without any preprocessor stuff. So let me think how we can do that. So we can do that by implementing this extern thingy. By implementing this extern thingy, some sort of preprocessor. introduce headers. So let's revert this thing. Not revert changes, but revert the whole commit. So I'm gonna revert this whole commit where we introduced this stuff, right? And now in the bosom we don't have defines or anything. Hopefully, it depends on this thing. Yeah. So I reverted everything here. So what we can do now? Rename, introduce header native functions, and in this step, do we still have? Okay, that's actually cool. We don't have this stuff either here. Nice. I was being semi-ironic up there. My point is that I personally don't support Windows because everything that has been established as a standard is somehow intentionally broken and different on Windows, so actually doing the heavy work of figuring out how that thing works on Windows is often not the worth the effort, because you immediately find the next step that doesn't work. Well, yeah, so another way to solve that is just not to do the work that can break on Windows. And the result is going to be even better. You're going to end up with a thing that works and also works on Windows. So yeah. So we're going to end up with something that works and works on as many operating systems as possible. So I think I'm going to go for that solution. Basically not do the work that won't work on Windows. And find a solution that solves the problem without that work. Okay, so let me take a look at the assembly. So our assembly is kind of complicated. We have a lot of repetition, but I think we can simplify this repetition. For example, if a thing accepts an operand, number literal as word. All right, do we use this? Would we use this in other places? Okay. So there's a lot of repetition, and the differences between these branches basically depend on whether the operand instruction accepts an operand or doesn't accept an operand. So that's kind of important. All right, so we have a token, right? And the thing we can do here, we could take a token and parse it as an instruction. Unfortunately, we don't have a function that accepts the name and returns you an instruction. So we have inst name, right? But we don't have an opposite one. So what we need here is an opposite one. You see what I mean? We need an opposite one. So let's actually go ahead and quickly implement it. So I think my water is already boiled up. So I'm gonna go to the kitchen. Don't go anywhere. Fucking coming, mate. What's up? I'm sorry. The previous flat was more streamer friendly. Excuse me? I'm not sure what you recommend. So we need a function, right? We need a function that returns inst type, right? But accepts the name, right? It accepts the name. But also this entire thing should indicate that we don't know the instruction. Oh, you mean the kettle behind? Okay, so I'm sorry, my brain is all over the place. Like it switches the context like 5 times a second, and sometimes I don't understand what you guys are talking about. All right. Okay. So one way to iterate all of that. Instruction by name. Right, so there's instruction name and instruction by name. So, but it might be missing. So we need an indication that, you know, something is wrong or whatever. We might as well actually return an indication that we found it, right? And we're gonna return through an argument. Instruction, this is just an instruction type. And it's gonna be the type. There we go. So what I'm doing here, I'm gonna iterate through the instruction type. So it's actually called output. So this one is gonna be type, and we're starting with inst nope. Yeah, we can start with just instruction type 0, but cast it to type. Then while type is less than number of instructions that we have at all, right? And if instruction name please Emacs, please, thank you Emacs, instruction name for that type is equal to the name that we have here, that means we found it. So we have to do strcmp. Right, here is strcmp. Oh, wait a second, I think the token is going to be actually string view. Yeah, I think it's going to be string view straight up. So that means after getting instruction name, we'll have to convert it to sv. What was that? IMenu. SV sister something, sister as SV. Yeah, it was sister as SV. There we go. So we have sister as SV. Then you have this name, sister as SV, and then you do SV equal. Yeah, SV equal. And you compare it to the name that you've got here. And if this thing is correct, you set the output to the type and instantly return true. Otherwise, if you went through all of these names, and never found it, the output is never gonna be set. So yeah, I think it's a reasonable solution for a C program. Alright, so now we have a thing that takes an instruction, converts it to the name, and then if you have a name, you can potentially convert it into an instruction, which is quite convenient, not gonna lie. So let's go back to BM translate source. BM translate source, so here is the token. So we have a token here, and then you can do inst by name. So you provide the token, and you want to have an instruction type here, right? You want to have an instruction type here. And let's put it this way, instruction type, inst type. We're going to initialize it with just instruction nope, right? And if you manage to find an instruction with that name, depending on what you have here, whether it has an argument or not. So if instruction has an operand, instruction type, you simply gonna be doing this thing. You're simply gonna append this instruction here. You see, we're just appending this instruction here, inst type, and that's it. If it doesn't have an operand, right? If it does have an operand, we'll have to do some interesting stuff. I think I'm gonna add label defer for all of the instructions that accept an operand. I think that's gonna be a thing. So operand count, operand count. What is that? Oh, okay. Yeah. So this is gonna be like this. So, and if we have has an operand, we do that. If operand is not starts with digit, we're trying to convert it. So we do have an interesting thing: number literal as word. So this one is not particularly correct. So essentially what I'm trying to do here instead is try to convert it to a number literal. If it's not a number literal, try to treat it as a label. I think that's going to be a good way of handling that. But that means I'll have to change the behavior of number literal as word, right? Because right now, if you have incorrect, if this thing is not correct, right? It will just crash your program. So we need to do a similar thing here, where we return the output via this thing, and a result is this. Makes sense? Hopefully that makes sense. Okay, so if we encounter something like this, we're gonna automatically return 0. Don't focus on not important things. Okay, so this is that, and this one is gonna be just 1 output result. So this is how we're gonna handle that. So essentially you try to convert a string to a number literal, like parse a number literal, and if you cannot do that, that means it's a deferred label, and you'll have to put it into the list of deferred labels. So okay, what else do we have here? So that should probably simplify this thing. You can do it like that, I suppose. So it's gonna be this without plus plus. I take the operand and number literal as word. So this is gonna be the output. The input is gonna be operand. The input is gonna be the operand. And if this thing succeeds, we just increment this stuff, I suppose. We just increment this stuff. Oh, that's very interesting. Otherwise, we still increment it, right? We still increment it, but also we have to add this stuff to the deferred list. This is so interesting, actually. This is... okay, so that means we treat it as that. So, and this stuff is not really needed anymore. This stuff is not really needed anymore. Okay. So, BM program size, not plus plus, but the type is going to be the same. It's going to be instruction type. It's going to be literally instruction type, which means that we don't have to do this stuff. So we can just yeah, holy shit, that simplifies so many stuff. That simplifies so many stuff. I like that. Holy shit, that's so cool. Like I'm trying to alright, so that means I can put this thing like that. So, and then I can just remove this thing. Okay, so we add that. So this is the type. If it has an operand, we try to parse this operand as that thing and assign that operand there. If we cannot do that, so that means we have to remove that and just do something like that. We don't need to do that. Holy shit, okay, and you know why I'm so excited, chat? Because this simple, like how many lines of code, 13, replaces all this shit. Speaking of piling code on top of each other until pattern emerges, well, there you go, we did it, so it... Basically, you don't need any of this shit. Okay, so if you didn't find instruction, you'll have to do something like this. There we go. Looks good to me. So, yeah. And after that, once you add an instruction, the only thing you will have to do is define whether it has an operand and what is its name, and the assembly will pick it up automatically. You won't have to think about that. All right, so we have a token, and you have an instruction, something, and you try to get it by its name. If you cannot take instruction by its name, it's an unknown instruction. Okay. If you found it by its name, you assign the current instruction to the type, and only then you check if it has an operand. If it does check has an operand, you try to parse the operand as a word, as a number. If it's not parsable as a number, you add it as a label, you defer it as a label, and try to handle it later. And one thing that I forgot to do is to simply increment program size, because we just pushed a thing there. So, and that simplifies things dramatically. It's probably not going to compile first try, but that removes a shit ton of code. And still should work. It still should work. All right, this is the whole assembly. Okay, let me see. It's going to be something like this, and make minus b. God damn it, reflexes. Alright, so something doesn't work. Inst, no previous prototype. Yeah, this is true. I forgot to add a prototype for this thing. Inst a name. So there we go. So this is where we have all of the prototypes here. Okay, another one. String view. It doesn't know what is a string view. Yikes. Okay, so where do we have a string? Well, I can probably move everything string view related like a little bit higher. Right, everything string view related, so we can put it at the top of everything, literally. Yeah, I think it's gonna be a good idea. Alright. Alright, number, conflicted types. Oh yeah, that's true. So I actually changed this thing. Number, literal. So here it is. So this is the new signature here. And invalid operands to binary. Yeah. Cool. It holy shit, it actually worked first try almost. I mean, as soon as I made it compilable, right, it actually worked first try, and I think we need to inspect the files that we've got. We definitely need to inspect the files. And if I take a look at the debusm fib bm, holy, it worked. Fuck me. This is so insane. Alright, so I can try to run some of these things. Let me rebuild everything from scratch one more time, just to ensure that everything's okay. And I'm gonna do BME. Input is examples. Fibonacci, how about Fibonacci? Fibonacci works. And what about E? E works. What about pi? Pi works, I suppose, and look how much shit we managed to remove from assembly. Yes, this is what I'm talking about, like just pile code, like pile spaghetti until the pattern emerges, and once it emerges you just compress into like a very compact small thing, and it's so nice. And I didn't even waste time thinking about what's gonna be the best way to do that. I just let the spaghetti grow, right? I just let the spaghetti grow, and then I just trim it off, just like my hair. Alright, let's drink a cup of tea. Does anyone have any questions, by the way? Oh, I look, you're here. Well, by the way, hello. Just let it grow. maybe I'll let it grow. I'm kind of afraid to letting it grow because if I want to cut it again, it's such a pain in the ass to shave it after a certain length. I'm here but lurking sometimes, I see. It's such a pain in the ass to shave it afterwards, so I just don't want to do that. Just don't want to do that. I mean the code. Ah, okay. I see. Shaving the coat is easier than shaving the head, trust me. Trust me. Alright. So let's do a committee, maybe, and even then, push it. Yep. Simplify BASM BASM translation algorithm. There we go. Let's push that right into the repo. What's up, Belgianul? Welcome to the streamers. Okay. What I wanted to do, I wanted to check how easy it is to add a new instruction now. So adding a new instruction should be super easy. Let's see. So essentially you want to add a new instruction, right? So instruction your mom, right? So let's see how easy it is to do. So you start the compilation process. You just start the compilation process. So it fails in some of the places. So that means you need to specify the amount of operands for your mom, right? So you have to do case inst your mom. And let's say that the amount of operands is going to be 1, right? So she accepts 1 operand. And another thing is you need to specify the name for your mom, right? Inst your mom, and we're gonna just return your mom. There we go. Still compiles because you need to also implement the behavior, right? So you need to once you edit a new instruction, you need to specify 3 things. You need to specify the amount of operands, behavior, and the name, right? Once you specify these things, it automatically works with assembly and disassembly, so you don't have to change anything. This is actually pretty convenient. So your mom is not going to actually do anything for now, it's just for the test, and there you go. You edit a new instruction, and furthermore you can now use that instruction in BASM. So let's actually go somewhere here, right? And let's put your mom here, right? So, and if you try to rebuild everything, right? If you try to rebuild everything builds, right? Everything builds. So there we go. And if you try to debug them now, example 123f bm, as you can see, your mom is here, and it has an operand like 0 because we specified that she has an operand. So I think we found some sort of a bug. So if we specify an operand like 69, right? So if we try to recompile this stuff one more time, okay. So it's kind of interesting. So right now our assembly allows you to use instructions that require an operand, and it will just use 0 as an operand if you never provided an operand. So, and it's kind of like, do we want to check for that? I think we want to check for that because it would be kind of convenient. But not now. Not now. I think I'm going to create a separate issue for that. It's going to be a separate issue. Of course, we need to remove your mom instruction because it's not needed anymore. I can recompile, and there you go. There's no that instruction anymore. And if you try to use that instruction, it's not going to be a valid instruction, right? So I can save this thing one more time, right? And if you try to build everything, it will complain a no instruction your mom. So this is how easy it is to add a new instruction. It's pretty cool. I doubt your mom takes only 1 operand. Got him. And by the way, I think in so we had an interesting issue here. Number literal as word. Right, as word. So invalidated bosom error does not print its location. Well, we don't need this thing anymore because this function doesn't crash anything anymore. So it returns 0, and if we need to crash because of 0, we're gonna crash in a location in a place where we know the location of the source code. So I think we kind of like implicitly solved this problem, which is kind of cool. So yeah, I'm gonna quickly do that. So let's say close 44. Since number literal as word does not crash the bosom anymore, it does not need to know the location. There we go. And let's push that right into the repo. All right. Cool. And again, I need to add a to-do saying that, yeah, if you do require an operand, I think you should fail if you don't provide the operand. I think it's kind of important because it may catch you off guard. So when that shit happens, well, I have an idea. So if instruction has an operand, and if the operand, right, the operand that we're trying to parse here, this one, it's empty, right? If it's empty, what we need to do here is throw an error like this. Saying something like instruction error instruction this, and we have to provide like a specific token and stuff like that. So we provide input file, a line number, and token. Requires an operand. What if it needs 2 and gets 1? We don't have instructions with 2 operands. We have instructions only with 0 and 1 operand. This is by design. This is not a bug, this is a feature. Alright. Looks good. So let's see if it's gonna work now. So let's go to one of the examples in Fibonacci, for example, and let's try to remove like here. And instruction push requires an operand. Cool. So now it actually checks that. I don't even need to create a separate issue for that. It actually turned out super easy to solve. Alright. Crash if no operand provided for an instruction for an inst that requires it. Okay, so I'm gonna push that right into the repo. How many to-dos we have? Okay, cool. So everything has been successfully refactored, and we need some sort of a preprocessor thing, right? We need some sort of a preprocessor thing that will allow us to define labels, I think. To be fair, we already have a mechanism that allows us to replace a name with a number or something like that. You see what I mean? A name with a number. Why not utilize this mechanism? Why not utilize this mechanism? So essentially maybe like ability to define custom labels, right? Something like label, you know, print F64, and it's going to be 2. So essentially, if you define a label, it defines a name that points at a particular address, at a particular number. Why not be able to define these labels like just like that, and point them at anything and just reuse them or something? So we can even try to do something like define it. Yeah, sounds like a good idea. 69. Unfortunately, we don't have 69-bit computers these days, but yeah. Alright, so let's literally call it define. But it's not going to be defined in a sense of So probably we're gonna call it something different. Yeah, that's the problem here. Okay. So what we're doing here, you have a token greater than 0. Okay, token count. And if it ends with that, that means this is a label. All right, this is interesting. So if token, to be fair, I think, look at that, we have condition that starts with token count equals 0, greater than 0, and another condition here. So I have a feeling that if we moved all of that like this, that would simplify this stuff a little bit. You know what I mean? Like it's just the same thing pretty much. Alright, so we have a token greater than 0. That means, okay, we're trying to parse the label and stuff like that. Instruction type, we extract it, and everything looks okie dokie karaoke. Alright, that looks cool. And unknown instruction empty. God damn, okay. So I probably forgot something important. Huh, what did I forget? That doesn't make much sense. What's the difference here? This is because of this stream thingy, which we don't trim here for some reason. We could have just trimmed it here then. Like, I mean, why not? All right, so we extract, we split line, we trim this thing. We trim this thing. And if this thing ends with that, okay, that's cool. So that means we still can put it back. So, alright, so I think this starts to make more sense now. Okay, so that should work now. Still doesn't work. Alright. So I trimmed that. Because after the... I see what's going on. Because after this thing, it may become empty. Okay, this is important. Okay, I agree. This is actually important. We need to keep it anyway. Yeah. Because the token may become empty after we consume the label. Yes, alright. So that actually explains it. Okay, so another thing, token count greater than 0 and token data, let's put it this way, is equal to that. Right, so that means we are doing preprocessor, right? We're doing preprocessor. Preprocessor label instruction. So we have like these three things that we parse in essentially. So if we hit preprocessor, I think we should not try to parse labels or instructions, so it kind of becomes pointless, but I'm gonna encode that a little bit later anyway. So here is the token data, and yeah, how can I chop a single character out of that? Well, right now it's not that easy, so I can always do something like token count -1 and token data +1. That will chop off that single character out of this thing. And after that, it would make sense to trim the token, right? So we're gonna trim the token and chop by delimiter or chop by word. SV chop by delimiter, and it's going to be a token, right? It's going to be a token, and delimiter is going to be space. All right, and that gives us string view directive, right? A preprocessor directive. This gives us the preprocessor directive. Right, this is the preprocessor directive. Cool. So, and if sv equal directive to label, right? We'll have to define a new label. So, but we'll need to get it as well somewhere. So, label name. Let's call it like this. So you chop by delimiter, right? And you'll have to trim it yet again. You'll have to trim it again and chop it yet again. There we go. So that will give you a label. And right, if label count is greater than 0, that means it was not defined. To be fair, we also have to do the following thing, right? Else unknown directive, right? Unknown directive. So this is what we have to print here. This is what we have to print here. Error unknown preprocessor directive. So instead of token here, right, instead of token, we're gonna use directive. There we go. So preprocessor directive. We may also split things up a little bit here. Right, unknown preprocessor directive, and there we go. So if you don't have a label, right, so here we can say something. Label name is not provided. Label name is not provided. There we go, and it's also going to be exit 1. All right, and so we have a label. We need to repeat this entire stuff, and what we expect in here is the value, right? The value. So it's going to be a number or something, whatever. I wrote string view. Yes, I'm programming in C, and I wrote my own string view. What do you redefine the label? I haven't implemented that yet. Holy fuck! Zozin, why your code is not finished? Well, I'm in the middle of implementing. Holy shit. Okay. Still on part 1, exactly. Cool. So we're chopping it off. Okay. Nice. So, and here is an interesting stuff, I think it's very interesting because, oh yeah, by the way, let me wrap all of that stuff into a separate thing here. So essentially, if we hit the preprocessor, right? If we hit the preprocessor, so we don't try to parse it as a label or as an instruction, right? So we might as well at some point separate these like sections into functions and have some sort of like a recursive descent and whatnot. All right, because right now it's a little bit intimidating for new developers who are used to writing functions that only fits into the screen because their professors told them so. But yeah, so we're gonna think about those new grads a little bit later once our source code matures. All right. So we have a value, and I think, can I treat that value as an operand? Number, literal as word. Yeah, we can try to do that. And when I'm pushing a label, I'm actually pushing the instruction address, which is not particularly great in my opinion. I think we should be able to push literally a word there, because word can be interpreted as an instruction address. Huh. Okay. That is very interesting. How long is the code? It's getting close to 1,000 lines, I think. It's actually a very small project, to be fair. Like, I mean, 1,000 lines is not that big. It's pretty close to 1,000. It's pretty small. Okay. Now, what's the most lines of the code you've written? How do I know? I never counted. And what does it even mean? Like, accumulated amount of lines throughout my life? Like, I've probably written like maybe like a few millions. Who knows? You know, I don't count that. Who in their right mind would even try to count that? So word. I want to have a word, and I'm gonna just try to initialize it with 0. Number literal as word. So we expect this thing to be a number literal. This is going to be a word, and if this thing was not provided, we're going to say something like this. Oh, that's actually pretty cool. So can remove that. So this is not label name is not provided. This is something like this is not number, I guess. It's not a number. It has to be a number. That's not a number. Hello. Why do we have highs? Hello, Renite HD. Is this Unreal Engine? Yes. This is Unreal Engine. Trust the chat. Okay, so we're gonna have to do like a value here, and then we're gonna exit. Cool. Isn't it cool? I think it's kind of cool. What is your smallest written code? I think I already showed that. I can show it one more time. This is my smallest code. It compiles, by the way. This is a valid C. Like, this is a valid C, straight up. And if you try to compile it, it produces an executable, but if you try to run it, it will segfault immediately. So yeah, it segfaults, but I mean, it still compiles. Who can tell me how this shit works? So this is the ultimate test on the knowledge of C. Smallest C program. Alright. So the idea is that C has a legacy thing called implicit int. So essentially, if you define a variable like this, that implicitly means int A69, right? So essentially, this is what we have here. So that means this is what we have here. So we define a variable main. But what we need, we don't need a variable, we need a function. But here's the thing, C is so low level that it doesn't fucking matter. Because if you, whether you define a function, right, a variable, or you define a function, what essentially you're doing, you're defining a symbol in an object file. Right, so you just define main symbol in an object file, right? And what linker needs is a symbol main in your object file to create an executable. So because it's going to use that as an entry point. So what you're essentially doing, you're making an implicit variable with the name of the entry point, and that appears as the name in an entry point in an object file, and linker thinks, okay, I can actually link that into an executable, and there you go, it just creates an executable that tries to execute something at that label, and that something results in a segmentation fault. And also it's external by default, yes. Do you know about do you know about IOCCC? No, and it sounds like some sort of a competition, to be fair. The International Obfuscated C Code Contest. Oh yeah, okay. I think I heard about it. It's actually still, yeah, they're still playing. Huh. Yeah, I heard about it, but then I forgot about it, and you reminded me about it again. So that's how it usually works. So it won't work. Depends on the definition of work. What do you mean work? I mean, it compiles. What do you mean work? Don't crash, maybe. I don't know, maybe, but maybe that's the intended behavior that you wanted from your program anyway. Who knows? So... Okay. Alright, so we're trying to parse a word, right? We're parsing a word and we're gonna actually put it here. And after we did that, I need to push a label. Something like push label. Yeah, this is what I need here. And here is an interesting thing. So we do have a name, we do have a bosom, I think. We do have a name which is a label, and the address is essentially... hold on, Clang accepts just main. Oh, wait a second. Are you gonna derail me like that? What? I already switched the context. Please, Nico. I already switched the context. Why would you do that to me, like at this particular moment? Okay, so... Okay, GCC also accepts that. Cool. So we can make it even simpler because it's... Yeah, thank you. Stop nerd sniping me. Start nerd sniping me. I'm joking, by the way. Everything's okay, Nico. I'm sorry. Sometimes I overreact when I'm forced to switch the context, so sorry. What language are you most comfortable with? Russian. So what do we have here? We have label and we have a word, and I have to do 64. There we go. But this is something that I really don't want to do. But maybe it doesn't even matter. Sorry for the rally. No, it's okay. It's okay. I'm constantly overreacting. It's my fault. All right. Buzz push label. I think that's okay. We need to probably change the notion of the label to do label should refer to word instead of inst address. There we go. I mean, programming language. Well, you exceeded your, limit on questions today, so I cannot answer that question. Sorry. Be careful with asking questions. If you ask a wrong question, you get a wrong answer. I'm not sure if you need XC. Well, you need that if you have a completely different extension. As far as I know, GCC uses different compilers depending on the extension, right? And if you have extension.c, you don't really need XC, if I understand correctly. Yeah, and yeah, so you probably need that for the standard input because GCC doesn't have any information about the language, right? May I ask what's the purpose of this VM for Lisp? Also, which Lisp is that? Emacs Lisp? The purpose for VM for Lisp is so we can take Lisp expressions and compile them down to that virtual machine, and virtual machine will optimize them and run them faster. What kind of Lisp is that? It's eBisp. It's our own dialect of Lisp, and you can find it here. Thank you very much. Okay, guys. Oh, okay, guys. So let's continue. And what am I even doing? Yeah. Let's try to recompile this entire stuff. Make minus b, and it's not make. It's actually just build. All right. So what do we have here? Sister as SV. Sister as SV, and it compiles. Excuse me. Why the fuck do you compile? Does it really compile first try? And if I try to do BME on the... Actually, let's do debusm. What's up, Shuggy Man? How are you doing? Debusm. Examples, fib bm. Okay, it works, I suppose. It works. And then e, and then pi. And if we try to execute them, they do work. So we didn't break anything. All right, so it's actually pretty good that we didn't break anything. I'm super happy about that. Yeah. So, but we don't use the preprocessor anywhere either. So let's try to use that somewhere. So let's go to the Fibonacci, and this is where I may try to introduce a label called n, and it's going to be 30. So, and in here we're going to just use something like this. So we're using 30. So it's a custom label that stores some sort of a value, and that value could be address or whatever, right? So it's basically a similar mechanism as doing this thing, but this label stores the address of the next instruction. Right, that's what it's doing. It just stores the address of the next instruction. That label stores a value that you force it to have. Right, and of course I forgot to check whether the label exists already or not, so we'll have to check for that as well. I think push label should automatically do that for us. Label, yeah. So I think we have find label address. Yeah, okay. I'm gonna do that a little bit later, I think. Bosom does not fail when you redefine a label. Will they clash names with address labels? I didn't pay attention to the implementation. Yes, I think they will. Okay, label name is not provided. Okay, I think I fucked up. Why label name is not provided? Excuse me. So, if it's greater than 0, so here's the directive. We chop this thing, right? Label name is not provided. So what I want to do here is essentially just print the rest of the the rest of the stuff that is not parsed, and the way we're gonna do that is like this. It's gonna be token count, but casted to int token data. There we go. All right, and label name is still not provided apparently. Huh. Okay, so this thing will start with that. We chop off that thing, and we trim the token just in case. We trim the token. And chop by delimiter. So that gives us the directive. We can test another interesting thing. For example, in fib, we can provide define and hope for something unknown preprocessor directive define. Okay, so this one is label. Cool. I made a very stupid mistake somewhere. I don't see it. So this is the label. Looks good to me. So I trim the token before trying to chop it by delimiter, and it turns out to be empty somehow. How does it turn out to be empty? And it actually is straight up empty. Oh, this is because I'm an idiot. Okay. I shouldn't use token. I shouldn't use token here. So what I should use here is the line. Token is just the token. Yeah, okay. And I don't even have to do it like that. So it has to be like this. So I just do that. And this is the directive. And the token simply is the directive. Okay. Token is simply the directive. And here, this is the token. All right, token is simply the directive. And in here, instead of token, we have to use line. So we keep chopping from the line, and that should actually work. And that fucking did. So, all right, so if I try to execute fib, it gives me that, and in fib, I can set 100, or maybe 96, I think that's what we have to set here, and that will give me more Fibonacci numbers. Right, that gives me Fibonacci numbers, so that means I can define these things now, which is kind of cool, I think, which is kind of cool. I wonder if what's gonna happen if I define like main label. Will it label n does not exist? Oh, okay, so yeah, that kind of makes sense. So, but we don't handle the collision of this entire thing. So yeah, that's kind of cool, not gonna lie. And we do native 4, right? In PME, a 4 is what? 4 is print U64, so that means you can do something like label print U64, and this is going to be 4, and print U64, and you don't even have to worry about any of this shit. You can just do that, and it fucking works. Yeah, let's actually go back to 30. Yep, and that's pretty cool. It just started to snow like crazy. Interesting. All right, so now we are reusing the label mechanism, and that's pretty cool. That's pretty cool. So we can define these things. We can define these things. Huh. I really like that. This is so cool. And another directive that we're probably going to have is include. So what it will do, it will just recursively start preprocessing the rest of the stuff. Right, include natives, hasm, right. So what that will mean is that the preprocessor will just go there recursively, if you know what I mean. Right, it will just go there recursively, and if you have any cycles, you're gonna be fucked up, sure. That's what's gonna happen. But that's gonna be like, that's gonna be it, I think. Okay, I fucking really like it. So if you try to do something like this, okay, unknown preprocessor include, and it even tell us where it's happening, but if it's that, and we don't need the preprocessor, so this is the main thing here. It will work. It will work on Windows easily without any stupid modifications, without any things, and you don't even need to have a separate thing to execute. It just works and it does everything you want. It doesn't do everything C preprocessor can do. For example, you cannot assign a label something like instruction push and then just use instruction like this. You cannot do that. C preprocessor can. But the thing is, I would argue that you don't need that in majority of the situations. So it's actually very rarely you need something like that, and if you need it, you can just use C preprocessor yourself. We already replaced the comment style for you. So it's not like we're forbidding you to use a C preprocessor. You can use it if you want to. And maybe because of that, by the way, maybe because of that, we want to use a different style of our preprocessor, right? So to basically enable you with using C preprocessor if you want to, for some particular like obscure reasons. I think it's a good idea. Let me actually do that. Yeah. Bosom PP symbol. Come. I'm 30 years old, by the way. I'm 30. Okay. Cool. Native instruction just calls special function. Yes, that's what they do. And they depend on the environment. So basically environment depends what native 0 means, what native 1 means, and so on and so forth. right? And this mechanism, the mechanism of these native functions, is used to bind to external native functions that you may need, for example, for allocating memory, or for printing on the standard output, or and so on and so forth. Because these kind of things you don't really want to be making part of the virtual machine, but native just basically enables the extension mechanism. It's like in WASM. Have you ever programmed in WebAssembly? In WebAssembly, there is a mechanism where you can import JavaScript functions, right, and call these JavaScript functions from the WASM. It's kind of similar to that. So, yeah, if it makes any sense. But yeah. So WASM PP symbol, and let's go. And it didn't really work. Do we even use it anywhere? Yes, we do, because I actually already replaced it. So if I try to do it like that, unknown instruction label. Okay, makes sense. Yep, and everything seems to be working. Okay, so we have our special preprocessor that uses percents, and by the way, it you can actually put spaces here. It's still gonna work, because we trim everything. I should probably tokenize that, but I'm not tokenizing that, sorry. I wonder if the comments work. Oh shit. I think you won't be able to comment it out. Yeah. Wait, you managed to comment it out? How did you comment it out? Ah, this is because it didn't start with the preprocessor unit, so it went down and then commented it. Okay, that makes sense. That actually makes sense, I think. But I think there's also a pretty interesting way to... No, you won't be able to do that, I think. What if you... I think I found a bug. Oh yeah... No, it still works. Huh. Oh, because it's... That's really interesting. That's really interesting. I think our parsing is actually super scuffed. So at some point we'll need to implement like a proper parser that, you know, tokenizes everything and just being a little bit more careful about all of these things. All right. So we have labels. Do we need to commit all of that? I think we need to commit all that. Should refer to other stuff. WASM does not fail when you redefine a label. Okay. Implement preprocessor and label directive. Let's put that right into the repo. So do we need to start documenting that? I think we need to start documenting that, because it's really unclear why this thing is called label. It's really unclear why it's called label. Because we're reusing the label mechanism that we already have. And maybe it shouldn't be called the label mechanism. Maybe it should be called like bindings mechanism, operand bindings. But I think label is a decent mechanism, I guess. Alright, so since we're reusing label mechanism for binding values and shit like that, I think we need to redefine this function a little bit. So here's the problem with this function. It usually binds a name to an address, right? So here's the problem. It binds a name to an address, but we're not necessarily using addresses there. How is the VM different from an interpreter? The script is in binary form. I guess you can put it this way, sure. And for example, your script in interpreted language can be just a compiler from the language to the virtual machine bytecode, and then the virtual machine will just interpret your script, I suppose. Okay, so WASM push label, and the thing here is that, yeah, let me go ahead and just rename this thing. So it's going to be not inst address, but it's going to be a word. So you're binding a name to a particular word. Well, this is Lisp. You can write a meta-circular interpreter if you want, probably. And an interpreter usually runs an AST tree, but VM runs linear stuff. Yeah. So basically, essentially, the compiler will take your AST and just straighten it up like to linear think, and yeah, it's pretty much. So, and here's another interesting thing. So this is a word, and I think instead of calling it push label, I want to call it bind label. And furthermore, I might as well even return integer indicating whether you successfully bound a label or not. So if you not successfully bound it, that means the label already exists, and you can throw an error saying that, well, label already exists, what the fuck are you doing? I think that's a good idea. Bosom push label, so it's going to be int, and this is a bind label. There we go. It's a bind label, and because of that we also have something like find label. Right, so we have something like find label, and it automatically fails. Okay, so this one is also interesting. So we can redefine this function. So it's now not find label but resolve label, right? It also returns integer indicating that whether you can resolve that label, and the output is going to be given through the argument as well. So basically, if you cannot resolve the label, you won't be able to do that. All right, and the label itself, right? The label itself is name plus the value, right? Plus the name and the value that is bound to that name, which makes it completely different from deferred operand. And this is something I was worried about. I was thinking that deferred operand and label are pretty much the same thing. Now they're completely different things, not only semantically but in practice as well. All right, so we have bind label and you can resolve label. All right, so bosom find label address. This is the new signature here. So this is basically the refactoring that I'm trying to do. And let's go to the compilation errors. So bosom resolve. Oh yeah, semicolon, of course. Classic. Classic. Okay, so resolve label. When you are resolving a label, you need to output bosom labels I word. I think that's gonna be the thing, and then we say that we resolved this thing successfully. Now, if we couldn't resolve it, we're gonna return false, and we automatically resolve this problem, because that means we'll have to report an error, and the place that calls this function already knows the location, so we won't have to worry about that. Yeah. So by the way, this is one of the cool things about using to-dos and binding them to issues, because sometimes along the way you can solve some issues and you know what issues you need to close. It's super convenient, in my opinion. I don't know. All right, so bind the label. Before binding the label, by the way, so resolve, you managed to resolve that, cool, and here's binding the label, cool. So first we need to see if we can find that label, So bosom resolve label. So what if I don't care about its result? I'll still have to do that. Word output. Ignore. Let's call it ignore. Right. So this is something that we're gonna ignore. If we manage to resolve this thing, we're gonna return false immediately. Otherwise, what we do here, we just put a word here and then return success, indicating that we managed to successfully push something there. All right, pretty cool. Okay, so what do we have here? Bosom doesn't fail when you redefine a label, and instantly we actually found the place where we need to do something. Okay, so you push a label, but you actually bind the label. if I couldn't bind a label, I need to say that label is already defined somewhere. The question is, where is it defined? It would be kind of cool to actually tell where it is defined, and I think we can even say precisely where it's defined, because we have a label here. So here's the name of the label, here's the word of the label, and we can also store the line number where that label was defined, because why not? So, and then we can use that information to, you know, tell you where that thing was defined. Isn't it cool? But maybe that's too like outside of the scope of the current issue. So error, a label, label, this is already defined, right? And what we have to provide here is essentially label, label what? Label count casted to integer, label count casted to integer, and label data. There we go. And then we just crash. All right, looks good to me. Looks good to me. And let's try to recompile that. So this is another place where we have to do that. Very similar one, but this one is defining a label through a directive. This one is defining a label as intended. This one looks good to me. Does it? Does it look good to me? Thank you. I'm really glad that it looks good. So instead of pushing a label, what we're doing here, we just bind a label. So bosom label, instead of word, we use program size. Right, program size, and program size is just size t, so we'll have to do the following thing, like as u64, and I think we have to do something like word. Looks very NCC with explicit error checks everywhere. I'm not used to this coding style. Well, have you programmed in Go? All right. Is already defined. Cool. So what's the next thing? Find label address. Okay, so here's the second path. All right, so we're trying to find a particular label address. Oh, and that's cool. Word output. We can call it operand. We can call it operand, and it's going to be 0 initially. So, and here, if oh, that's cool. Oh shit. It's probably gonna, I'm probably gonna hit some sort of like a undefined behavior. Okay, I provide the label. So this is the label I'm looking for. This is the label I'm looking for, and this is the operand to which I'm gonna output the result. Right, to which I'm gonna output the result. Like this. And if I couldn't do that, we can put it like that, but I won't be able to actually print that anywhere. Like, yeah. So I'll have to do it like that. So if couldn't find that, error. So because we don't know the location, we don't know. I can probably add the input file though. I can add the input file, but not the line number because we don't know where all that is defined. We can also store the line number in deferred one. So we don't have a token count, unknown instruction, and what is that? So here's the label. To be fair, the label is just a name, so I can just do something like this. It's going to be string view label, like this, and that's kind of cool. Label, okay. unknown label, and here we can just use like this. So yeah. Alright, let's try to compile that. Resolve label. It fucking compiles. Surprising. Fucking compiles. And if I try to, for example, jump to your mom, it will say unknown label your mom. That's perfect, actually. Cool. Seems pretty good. Seems pretty good. So, but there is a couple of problems here. Is that we don't know the location, right? Second pass label resolution errors don't report location. The location in the source code, right? So this is something they don't do. And there is another problem. So there's another place where probably don't report. Wait a second. I forgot there was another place where I wanted to do that, where I needed to know the location, but I forgot that place. Where was that place? So here we have an error. Yeah, we have that. Maybe it was not that important. Okay, looks good to me. So if I take a look at this stuff and I try to execute that, pi, all of that works. Cool. All of that works. All right. So what we did here is, yeah, we essentially made the label more general mechanism, because before a label was storing only the instruction address. So here's the thing. It was only storing the instruction address. Now, a label can store anything. It can store a word, which can be put on the stack, or maybe interpreted as an address, or maybe interpreted as a float. It may be interpreted as like any value. And now, label is something that can be resolved as an operand. So it's a more general mechanism now. Oh, by the way, I just remembered what I wanted to add. Redefined. Already, yeah. So this, yeah, I just remembered what I wanted to have. Label redefinition error does not tell where the first label was already defined, because I think that will be actually a kind of useful error message, right? So label is already defined, but where was it already defined? Like, you can tell it because we can remember that. So where was it defined? So, and we even have a structure that stores the label, right? Right, and we can just put it here. We can put the file name there, we can put a line there, and we can just extract that information and just bring it to the user, because we know that information. We can know that. We don't know it now, but we can know it because we can track it. Alrighty, so make labels bind, not only bind to words instead of inst address. Let's put it this way, bind to word instead of inst address, and I can push that right into the repo. How many to-dos we have here? We have 2 to-dos, and that's pretty cool. They are gonna be completely separate issues. All right, I want to make a cup of tea. Does anyone have any questions right now while I'm making a cup of tea? Like any on-topic questions or anything? So yeah. We're working on a preprocessor support, right? So right now we edit a mechanism that allows us to bind a value to a label of some sort, and the next step is going to be implementing a preprocessor directive that includes the file, but it's not technically include the file, right? What's tea? Earl Grey. It's gonna basically recursively call the translate, right? So we're not gonna operate on that like on a level of text and files and stuff like that. So if the translator encounters some sort of include or import, it just goes recursively there. And of course there could be cyclic loops and stuff like that, but we can resolve all of that later. We can think about how to resolve that later. My point is that it should never stop us from implementing that feature, right? Because these problems can be addressed later. These problems can be addressed later. All right. Does anyone have any questions? Maybe on-topic questions? Maybe not on-topic. I don't know why I'm focusing on the topic. I kind of like what I'm doing right now. It's kind of cool. It feels like designing like a programming language, but it's such a simple programming language. You don't have like this like mental overhead with like juggling ASTs and stuff like that. It's actually very simple. It's a super simple programming language because it only has like instructions, labels, and stuff like that. So that's pretty cool. So we have deferred operands. So this is the whole context of the compiler, whatever that's supposed to mean. So it only keeps track of the labels and deferred operands, right? Because the operands that use the labels. Any questions? I suppose everyone is just keeping the stream in the background and working on something. So, okay, I have a question for you. What are you working on right now? Right. So since no questions, that means everyone is working on something. Maybe you're doing like your job, a daily job, and you're watching me while doing daily job, or maybe you're working on your pet project. I'm working on a game. Nice. Are you using any engines or anything like that, or is it like custom handmade stuff? A Kanban board in Go. Oh shit, that actually sounds cool. Working on my daily job from Absolute Zero. So Kanban. Let me take a look. A real-time persistent Kanban board. Okay, it's a web application, so the interface is kind of cool. Nice. All right. This is meant to be used only by me. Okay, that's good. That's good. Was put together in a hurry, less than a day, and it's absolute disaster. Classic. Don't worry about that. Everyone's code is an absolute disaster. Okay, so it's just nothing to be shy about. I think the problem is that like people quite often very shy about their code, thinking that it's, you know, trash and stuff like that. But the truth is, everyone's code is trash, so there's nothing to be shy about. So essentially the trick is to just accept that, embrace that, and yeah, just learn how to deal with trash code, and that way you will be able to read anyone's code. All right, so somebody's working on their daily job. I'm working on a free software Gothic engine reimplementation. Holy shit, that actually sounds very cool. Making an iOS app for my work. Cool. Chip 8 emulator side project. Huh. I'm working on... I was actually right. So everyone is actually like keeping the stream in the background and just working on their projects. Yeah, that's cool. Using 2 different languages, C++ for frontend and Python single-player server. Oh, okay, like a Minecraft does. Gable having lunch. I'm taking the day to clean things up. Oh, yeah, you mean for the Kanban, I suppose. To be honest, I'm used to watching VODs and I forgot that this was live. Oh shit, that could be another hypothesis. Maybe like everyone is watching this stuff on YouTube and they don't expect this stream to be interactive. Was handed over other people's PRs to clean up. Yikes. But I mean, it's needed to be cleaned up anyway. Somebody has to do that. Job currently developing a website and associated services. Project is about fleet track GPS tracking. Stream is on the second monitor when not used for documentation. Cool. Is it interactive? Yes. All right. That's pretty cool. You guys are working on so many interesting things. All right. So I'm gonna go to the kitchen and turn on the kettle for some tea. Don't go anywhere, or I'm gonna submit a pull request to your project. And trust me, it's gonna be a big pull request and you'll have to review it. It's gonna be 1,000 lines of code. Hello. What is Lisp? It's a family of programming languages. Okay, so let's continue. Let's continue. Did I commit everything? I think I did in fact commit something. Moved to the kitchen, made a cup of tea, and watches the winter do its work while working on some C code. Nice. All right, so let me take a look. Where's the label directive? BM translate source. So this is how we translate in all of that. So here's the label, right? And another one is gonna be else if. Let me see. So what we're gonna call it? We can call it include, right? So essentially it will include the other file. And what we want here is probably, yeah, we're gonna use quotation marks, if that makes any sense. Example. This one is interesting actually, because that means you also need to introduce the notion of include folders and stuff like that. It's probably going to be kind of painful, but we'll see. So it's going to be examples, not bosom, but fib, right? It's going to be fib, bosom. So essentially I just want to create natives. We already have natives. And instead of defines here, I want to have something like label. So these things will become labels. And then we can just do something like include labels natives. There we go. So this is going to be our own preprocessor. So, and what it essentially does, right, it just recursively calls the translation process. It just calls the recursively translation process, and we don't even have a function that would say translate the file and whatnot. So we have an input file path, and we do accept the source. So we need a function that would do something like bm translate file, right? Bm translate file. Bm translate file, and I think it's going to be, it takes bm, then the bosom context, and it should take only the input file path. You know what? I think I can change the definition of this thing, right? It's not going to accept the source, period. It's only going to accept the input file path, right? And the way we're going to treat all of that is that we're going to just read that source. We're going to just read that source from the file. sv slurp file, right? So this is the function that slurps the file. It's pretty straightforward, and we can just use input file path. There we go. So now we can call this function recursively. Isn't that cool? So yeah, we can literally just call it recursively, and we're gonna reuse the same context, and we're gonna reuse the same virtual machine context and the same translator context. So basically it will include the labels and stuff like that. Labels are not gonna have a separate scope. Though that would be a very interesting idea. Imagine like including a file and the labels that you use there, they have some sort of a prefixes or something like that, so they're not gonna interfere with labels in your current file. So we can have something like that. That's actually pretty interesting. And you won't be able to achieve that on the level of C preprocessor. So we're getting into the area where like we can do things that C preprocessor cannot, because it doesn't have enough information. And this is, by the way, why preprocessor has to be part of the compiler. So they have like enough information to do all this cool shit. You see what I mean? Right. So like this decoupling is completely useless. Like, I mean, we'll only lose information. Yeah, file slash label. Why not? File slash label. That's actually a pretty cool idea. But we're gonna do that a little bit later, not right now, because it's too much of a scope. So we just want to focus on a very simple thing. Okay, so here's include, and before trying to do anything else, line SV trim. So we're trimming the line, and what I expect here is I expect the line to start with quotation mark. And ability to alias includes too, to not write long files names all the time. We'll see. Even folder file label, maybe. We don't know how to implement that yet. We don't really have enough information. It's just a rough idea. Maybe we don't even need that. It's kind of hard to tell if we even need that. All right. So if so if count is less than 0, we can say that a file path is not provided. Label name is not provided, but here we have something like file path is not provided. Error. File path, include file path is not provided. So this is basically what we have here. Include as lib. That's not a bad idea. Holy shit, this is not a bad idea. But not bad. Because we can literally, we don't even need to translate shit, because we can just take the instructions from that binary file and we just can append it to the program. So just nothing is required there. Like, what the fuck? Oh shit, also the positions of the labels are gonna be affected or something? Are they gonna be affected? No, they're not gonna be affected, I think. Alright, we have to be still a little bit careful with all of that. It's really interesting. So, but the problem with including like BM files is that we don't have any label information there or anything. So that's kind of the problem. Welcome back, Adnan. Anyways, so all of that is outside of the scope of what we're doing. It's all outside of the scope. So we just need to implement includes, and we're good to go. So then, once we have something working, even though it's scuffed, we're gonna have enough information to deliver. All right. So I'm gonna go and pour myself some hot water. What do you mean outside of the scope? I thought it is a derailing stream. No. Chat, no. No derailing, please. Alright, so here's an include, and I expect this thing to start. Wait a second. I don't think it can be equal 0, right? If it's equal to 0, alright. If it's greater than 0, otherwise we're gonna do that. Cool. If Jiang, oh my god, welcome to the stream. If line data does not start with this thing, so if it starts with that, right, and line data line count -1 starts with that. This is not what I wanted. I wanted these things. Then we're gonna treat this entire thing as the include path. So the path in our case is gonna be, I can try to do something like this. Data +1 count -2 to account for 2 characters. Yes, to account for 2 characters. Alright, and then we can use line as that. Otherwise, we can say that the path has to be surrounded with quotation marks. Include path has to be surrounded with quotation marks. I think this will win here. Alright, and after that we're gonna call BM translate source recursively. Right, so it accepts BM, bosom, and this line. Cool. So of course you can start recursing this thing. And we probably need to keep track of whether we already visited something or not visited something. I don't know, but I think the easiest approach would be to do something like to keep track of the level, right? Just keep track of the level, right? If the level is greater or equal bosom include level, max include level, right? Something like max include level. We're gonna throw an error, right? We're gonna throw an error. What kind of error we're gonna throw? That's a good question. That's a good question. And by the way, do we even clean the files after we, you know, read them? We probably don't. Oh, we definitely don't. That's right. We definitely don't. And this is something we have to do. We have to free source. And source being modified all the time, so yeah, we have to do something like that. Source view original source. So this is going to be like this. So here's the original source, and here's the source that is the input, and then we always take the original source and we free original source data. So this way we don't leak any memory, hopefully. So, and if you hit the bosom max include level, we probably want to print something. I'm super sleepy, so I'll be mostly... That's okay. That's okay. Majority of people here are just lurking, actually. Don't worry about that. Don't even worry about that. We're implementing preprocessor for our assembly, so... and it's actually hella interesting, not gonna lie. It's actually hella interesting. Maybe this is what I'm gonna actually put into my title. Yeah, I think it would be kind of cool to put into the title. Writing preprocessor for my for my ASM. Okay. Cool. So, and we can print the error here, but we don't have enough information. Like, we don't have the location to print. We don't have the location to print. So what I think I'm gonna do here is I'm gonna go to the recursive call of BM translate. Right, and I'll have to put a level here. Right, and what's cool is that here we do have enough information. Level plus 1 greater or equal bosom. What was the in max include? What was the bosom? I think I didn't define it. Include maximum include level, right? Then we're gonna throw an error. Then we're gonna throw an error saying something like exceeded. Is this how we spell it? Exceeded maximum include level. Right. I think that's how we're gonna do that. Yep. And I guess that's it. So this is how we're gonna do that. It was gonna be the bosom maximum include level. That's a good question. This is actually a good question. So define, let's say 69. Guess what's gonna be the capacity of that feature, right? Guess the capacity of that feature Tsoding is implemented. Alright, so that's cool. So is it gonna compile? Let's find out. It's probably not gonna compile. So BM translate, yep. The signature was modified, so I have to put it like that. So line, oh my god, I hate it. I need to use string views as file paths yet again. Why C always makes it so difficult? Like, why? Why can't I just like use file paths that are sized? Why do they always have to be null terminated? Like, it just ruins everything. It just ruins everything all the time. It makes me so sad. Makes me so sad. And I already kind of do all of that, so number literal capacity. I can do a similar thing here. Just basically have a capacity and just use that. That's why I made string view struct for my make program. Okay. But the thing is, like, if you... That's not the point. The problem is that eventually you will have to pass that string view to a function that opens a file. And literally all functions that open a file accept null terminated strings. And there's nothing you can do about that because they eventually map to the open syscall that also accepts null terminated strings. You need to modify a fucking kernel to change that. It's like a fundamental thing that you just cannot avoid, no matter what you try to do. Yeah, because old code, like, it's like a... Modify Linux kernel. We're not gonna modify Linux kernel, okay. Though, I think that change would be actually super simple. Right, just accept, and this is something that bothered me so much, like, I'm not gonna lie. Read and write syscalls, accept buffer and the size. Open syscall accepts null terminated strings. multi-native string. Just accept also, just have a version that also accepts buffer and its size. And I'm pretty sure on the side of the kernel, it's not that difficult would be to change that. Like really, how difficult would that be? How difficult would that be? That's a good question actually. Kernel.org. Why the fuck am I downloading source code of Linux? Zozin, stop! Zozin, stop! You have shit to do. Stop. Okay. Holy fuck, that's a lot of crap. Do I have enough space at home? Yeah, I do have like a 13 gigabytes or something. It shouldn't be that difficult. I'm not gonna build the kernel, okay? I just want to take a look at the source code of the sysopen. Holy shit, that's a lot of crap. Alright, I'm pretty sure I'm gonna regret that. Sysopen. Okay. Oh shit, that wasn't even that bad. Okay. How about this? Compat sysh no libc open do open. Okay, so we have a file name, open how, build open how, do sys open at. So there's also open at too, but I'm not sure what the fuck is that supposed to mean. Okay, so far so good. So I would assume that this is the entry point to this thing. Build open how, and all right. File open name. File open a file and return file pointer. Huh. Interesting. Struct file contains path to open flags as per open second argument. Do sys open. I want to take a look at that one more time. So do sys open. Oh, okay. Here it is. File name. Okay, so it has to be do sys open at 2. So that's what they're using. Yep. File name. Right, so here's the file name. It uses struct file name. Get name. Don't fucking tell me that what this syscall does, it takes multi-native string and converts it to something that is a sized string inside of the kernel. Don't fucking tell me that. Holy shit. Like, why did I look into that? Because now I'm even more triggered. Holy fuck. Why are we doing that? Like, I want to take a look at the definition of struct file name. Is file name size? Let's find out. I'm really afraid to look into that because I'm pretty sure I'm gonna get even more triggered than that. Struct file name. Well, let's probably a bad idea. Okay, so here's this file, struct file name, a pointer to actual string. Probably not, but I'm not sure if it's the same struct file name. Pointer to actual string. So sys open. It could be a completely different thing though. So get name. I wonder where it's defined. Get name. So it definitely returns a struct file name. It actually returns a pointer to the struct file name. So assuming that I know what they mean, it's probably so something like struct file name get name, something like that. It's probably defined something like that. Hopefully. No. Okay. It could be maybe like this. No. Huh. Okay, so what about const? Okay. I think I found it. Okay. So it accepts const char and get name flags. Get name flags. Get name flags. I think I need to. It's really strange. Get name flags. Okay. We already take len. We already take len. You see, we already take len. Set. How do you set a show search? Yeah, this is what I want to do. So result is a file name. Okay, I don't think it particularly converts this to a size string, but it does need its length at some point anyway. So they do need the length to, you know, align things properly or something like that. So it's not as bad as just converting a sister to a sized one, but still, they still take the length of it to compute something. What exactly they're computing, I think it's irrelevant. So yeah, I guess it's relatively easy to do that. Uh-oh, stinky. We have a name that's approaching path max. Allocate a separate struct file name so we can dedicate the entire name cache allocation for the path name and redo the copy from the username. It's kind of fun reading the source code of Linux. So I wonder how many of such comments we can find. By the way, obligatory fuck. Oh, they probably recently removed all of them. No, they do have that. The in interval type is use64 in order to deal some type in our computation that prevents mindfuck issues with the overflow sign and division. Nice. Oh shit, wait, what the fuck? Torvalds fucked it up, smiley face. Oh shit, this is so nice. Torvalds fucked it up. We found the mark in the IDR at the right WD, but it's not the mark we were told to remove. We very seriously fucked up something. It's just people blaming each other. Am I fucking pedantic or what? Who wrote that? I'm pretty sure Dennis wrote that. This sounds like Dennis, like straight up. So I'm pretty sure Dennis wrote that. I didn't do git clone, so I don't have a git information. So I literally just downloaded the tarball from the kernel.org. So yeah. Am I fucking pedantic or what? Nice. Fucking love it. Black magic? I don't see anything. Maybe I missed it, I'm sorry. Avoid fucking up the memory controller. Nice. Wait, what the hell is that? Fuck, I hate NVIs. Okay. Alright. Cool. So yeah, I'm pretty sure it's not that difficult to change, right? To make open accept the size string instead of sister. Like it's just we're kind of stuck with that. We're kind of stuck with that, and there's nothing we can do about that. Okay. Oh, and I forgot that it was what I was complaining about. We need to make this thing string view. That's right. This is what we need to do. So this is going to be a string view. There we go. So input file path. All right. And that means I also have to update this entire stuff. Input file path string view. I think that the problem with size string is that the size could be wrong. Probably. So the same can be with null terminated strings. They could be terminated way outside the allowed memory. So the same situation, in my opinion. Yeah, exactly. So it's just like it's not the right argument for this situation. Like everything can be wrong. Okay, so when we're slurping the file, we actually have to accept a string view. Right, and within this slurp file, we'll have to allocate the memory and deallocate the memory. Cool, I'm really happy about that. I'm really happy how to, yeah, we'll have to do 2 allocations or whatnot. Not necessarily, but maybe. Anyway. So S expects char. Oh shit, and now, oh fuck, oh shit, oh fuck. Now, every time we use this thing, what I have to do is count int. Somebody kill me, please. And we'll have to do that everywhere, baby. For fuck's sake. And this has to be like that, yes. Fucking everywhere. Fucking everywhere. Yes. Make a macro. That's actually a pretty cool idea. Some random def 69. Thank you. It's actually like a similar approach as with SDL callers. Are you trusted? Are you trusted? I'm gonna trust you. I'm gonna fucking trust you. There we go. So, you're now trusted. So where do we define string view? Right, where define the string view? So this is where we define it. So what we're gonna call the macro? I don't fucking know. It could be sv count, integer, and then sv data, like this. Might as well do it like that. Sure. Yeah. Boom. So how are we gonna call it? SV format? SV format? SV format. And do we have a G anywhere? Nah, I'm not gonna do that. Alright, so so essentially what we'll have to do here is just SV format. It's kind of similar to like PRE, you know, I64 and U64 and shit like that, you know. SV format. That's actually such a cool idea. Why didn't I think about it? Thank you, some random dev. That's super cool. It's just, yeah, SV format. And god fucking damn it, mate. Just do it like that. Oh my god, I'm fucking coming. Yes. Yes, more of this shit, please. That simplifies my life dramatically. Okay. That's so cool. SV formats. Holy shit. Alright. So, how was your day, chat? While we're going through all of this madness, we can talk about something. Do you guys want to talk about something? Do you guys like C programming language? Do you guys think it's a good programming language? Or should it finally be replaced with Rust? Still working. I see, I see. Remember, chat, remember. No matter how difficult the task is, no matter how much of an idiot your boss is, you still gonna get paid at the end of the month. Remember that. And that's what's good about office job. Cheers. No matter what you do, you're still gonna get paid at the end of the month. Remember that. It's very important. And furthermore, it's really difficult to replace people in the software industry. So yeah. Haha. Haha. Unless the contract ends. Yeah, so you have to be always careful. You have to always consider your current situation and stuff like that. X equal x, x plus plus. What is x? I don't know, you tell me. I'm not doing coding exercises for free. Alright. Sweet format, file path. SV format, like this. Cool. Alright, so, and on top of that, we're also freeing this entire stuff. And what is it saying? Passing free discards const qualifier. Yeah. So essentially, we have to do void star to free everything here. Okay, cool. So we finally reached the point where we need to do something about this shit, right? So we need to do something about this shit. And what we're gonna do about this shit? It's a good question. So we're gonna allocate a sister malloc file path count plus 1, right? Count plus 1. If sister is null, well, could not allocate memory for file path. Could not allocate memory for file path, which is absolutely ridiculous situation, but it is what it is. Then we do mem copy. So destination is sister, by the way. Something like this. It's gonna be 6. Destination is sister. The source is file path data. And how many things we want to copy there? We want to copy count amount of things. And after that, sister file path count is going to be equal to 0. There we go. And the only thing we need to do here is just file path. foil path sister. This entire thing could be just called, you know, file path sister. And this could be file path SV to indicate their different types, but maybe fuck it. Maybe fuck it. File path path sister. Cool. And at the end of this entire stuff, this entire stuff, you should not forget to free your file path sister, right? Don't forget to free it. Cool. Let's try to compile this shit now. Is it gonna compile? File path sister. Okay. Anything else? Okay, so this is a file path, and I think everywhere here I have to query replace file path with file path sister. Actually, could not allocate memory for the file path, and we can actually print that file path. I think we can do something like SV format. I think that would make sense. Too many arguments. And we can also do something like this. What's up, John? Hello, welcome to the streams. How are you doing? Really glad to see you, by the way. Okay. File path sister, and is it gonna compile now? So everywhere here, I think we can just use sister because I'm too lazy to do the format stuff. The format stuff. Okay, and here I'm. Oh yeah, so this is a completely different situation. So we have an input file path, and this thing should be string view, I would say, and we can do something like sister as SV, and that should work, I think. All right, so, oh, and we don't have a source anymore, so you don't have to even slurp anything, right? So essentially you just provide the file path as that, and it just works. We might as well actually keep the original one, I think. I think it would make sense. And I want to use sister as file path here, like sister as SV. So what else? BM translate too few arguments. Oh, you also have to provide the level. We need to hide the level somehow. There we go. Native. Oh, it fucking worked. It mother flipping worked. Because now, if I do examples, fibs, bosom, it compiled. So it doesn't have a concept of include paths or whatnot. So that's kind of the problem. It doesn't have such concept. So yeah. And yeah, it's pretty cool. So that means we can have natives. We can probably comment them out and just observe some errors. For example, a no label print u. And I don't quite... so we have a problem that we don't print the location where that exactly happened, like a known label and whatnot. So we're gonna fix that a little bit later, but yeah. So, and as you can see now, we have a simple preprocessor that can define new labels and also include files. We can try to do an interesting thing, for example, in fib bosom. I can try to include ourselves. Examples of fib bosom, and let's see what's gonna happen. And label alloc is already defined. Oh, that's very interesting. So it's not gonna even, you know, it's not gonna even try to overflow in this particular situation because you keep including more and more labels and you redefine labels. So we have like several layers of protection from, you know, cyclic dependencies and whatnot. But maybe at some point we're gonna even support them. But yeah. So furthermore, include to do. bosom include directive has no support for include paths. I think that would be kind of useful, like to have include paths and whatnot. Alrighty, so, and we don't have any dependency on C preprocessor, right? Any dependency on C preprocessor. And look how easy it was to implement. We managed to achieve something GHC developers couldn't achieve for years. We did that in a single stream. So GHC, for those who doesn't know, GHC for the longest time was dependent on CPP, C preprocessor, for conditional compilation, right? So we managed to implement like a small subset of CPP for our purposes, like in a single stream, and yeah, so that's already better than GHC. I'm joking, of course. Like their situation is completely different, but still. All right. Oh shit, that was a lot of stuff. What's the limit of string view? What do you mean? Limit of what? Limit of the size? I think size T. And size T is unsigned 64, I think? I don't remember which one is that. I think it's a long int. I think it's good enough for our purposes. Size of pointer. Yeah. Alright. So I also want to go through all of the examples and make them use the preprocessor now. So it's going to be introduce, include directive, right? Introduce include directive, and let's push that right into the repo. So so now I need to go through all of the examples here. So here's the bosom, and we have a native, and we're gonna just include examples, natives, Hasm. I think it's called Hasm. Yes, it's called Hasm. And here I'm printing print F64. Print F64. Let's try to compile that. Seems to be compiling. Next one. Yep. Include examples, natives, bosom, and what we're including here is print I64. Cool. It's because it's Hasm. Couldn't read file. It would be better to actually also indicate the location of this thing, but we can work on that a little bit later. Allocation. This one is interesting. Right. Include. Include. Not hash for include. I couldn't understand what you're talking about. You mean this thing? Because we don't want to interfere with the CPP. And yes, it's not a joke. Essentially, the idea is to not depend on CPP, but if you want to use a CPP, we try to not interfere with that. Make sense? Yeah, because our preprocessor can do some things, some useful things, but it cannot do everything that CPP can. And maybe you need something extra and you want to use CPP, and we just don't want to interfere. So, yeah. Make sense? Make sense? If it's... probably I won't understand the without the context. Okay. I see. Alright. Examples. Examples. Natives Hasm. Right. So here we have a lock then we're printing a pointer and then we're freeing it. There we go. So now we don't need to define on depend on any of this stuff. We can also do something like label memory size for 20, and here we can even define it like so. So memory size. There we go. Yeah, and it's probably even more readable. Who knows? Okay, unknown alloc natives. Did we fuck up? Did we really fuck up? Like, why alloc is all of a sudden an unknown label? Didn't we add that thing here? I think we found a bug. I think we straight up found a bug. So if I put like 0, it seems to be compiling. So it works for print pointer or anything. Excuse me. Why specifically alloc? Alright, so troubleshooting time. We can actually try to debug that. Oh, let's actually try to debug that. I think it's going to be a pretty cool idea. So what I'm going to put here is GGDB, right? So we're going to try to recompile all that with this stuff, and I'm going to go to bm.h. Unknown label. So there's only one place where that happens. So if we couldn't resolve that, and what I want to do here, I want to actually look into this thing. All right, I want to look into this thing. Oh shit! I'm an idiot. I should not free on you any of these things. I think I know what is going on, chat. I know exactly what is going on. Borrow checker would have prevented that, unironically, actually. Because basically the memory allocated for the file does not survive enough time. Like, I'm not even joking, borrow checker would have prevented that. Because it's a lifetime issue, it's literally a lifetime issue. But the problem is, how are we gonna even allocate all of that? We need some sort of like a convenient custom allocator that we can simply deallocate after the whole translation. Nah, you don't need ArrayAI, by the way, to solve this problem. So ArrayAI, it's not a good idea here. So what we need here is arena, right? So essentially we need a huge arena where we can keep allocating memory into, and in the bosom, once everything is done, we can just deallocate it at once. Yeah, we just need a linear allocator. I think it's a good idea here. Let's actually freaking do this. Yeah. Just a linear allocator would be nice, and will actually remove so much headache. Maybe we can even put that into the bosom. Bosom like this. Right, so because we already have like labels, deferred operands, we can just you know, have some sort of a memory buffer. Memory. And it's gonna be bosom memory capacity. Right, and it could be like a pretty big capacity. We can pre-allocate like a huge amount of memory and keep allocating there. So it could be something like bosom alloc. So you accept this thing. So this one is size t. Memory size, right? And how much do you want to allocate there? So something like this. It's pretty straightforward. And in all of the places where we do malloc, right? Where we do malloc, we're gonna simply just allocate into that memory thingy, majig. All right. So it's going to be a temporary solution. Maybe we're going to have this as something else. All right. So how much do I want? Let's allocate 100 megabytes. I think that will be all right. Just 100 megabytes. Why not? Why not? Bosom alloc. Bosom alloc, and we never have to deallocate all of that. We never have to deallocate that. Bosom resolve label. Arena allocators make manual memory decent. Yeah, in some situations I would agree with that, I guess. Okay, so we're gonna assert some things. Essentially bosom memory size plus size greater or equal bosom, actually less or equal bosom memory capacity. I'm gonna just quickly hack this together, right? Simply hack this together. So result in our case is gonna be bosom memory plus bosom memory size. Then we do bosom memory size plus the size and just return the result. There we go, here it is. We just implemented that. How about that? We just implemented the linear allocator. Isn't that amazing? Isn't that amazing? I think it's quite amazing. So let's take a look at all of the mallocs that we do here. So when we slurp in the file, I think we need to rename this file because it's going to be using bosom context. Where are all of the bosom files? So bosom alloc, bosom slurp file, so it accepts this thing, and it also accepts the bosom context, so that means it slurps this entire thing into the bosom memory. So sv slurp file, so now it is a bosom thingy. Cool, and now we allocate this shit. So how many times we use malloc here? That's a good question. Only 2 times, so it's gonna be bosom alloc, bosom malloc, bosom alloc, bosom, and we don't have to worry about that. That's cool. Where is the other? That's it. We don't use malloc anywhere else. Holy fuck. So that was actually 2 things here. Nice. Okay, so can we recompile that now? So we don't have slurp, it has to be bosom, and we do have the bosom context here. And exited abnormally, so you were trying to, yeah. So, and now we don't need to free that, by the way, we don't need to free that. So you don't try to free a thing from a linear allocator. You don't have to worry about that. Where are the other things? So, all right, and it works beautifully. I really like that. Okay, so in the bosom itself, in the bosom translator, I think I want to actually allocate this thing. Yeah, okay, I'm already allocating bosom on a static memory, which probably results in a very huge file. No, it doesn't actually. So it's not that big of a file, even though I'm allocating 100 megabytes. Do I? Right, so kilobyte, megabyte, 100 megabytes. We can try to allocate, I don't know, gigabyte? Is that a gigabyte? I think we could try to allocate a gigabyte. So, yep. Yeah, okay. So we have a gigabyte of memory in a static memory and just we're using it. The thing when you try to free pointer to static memory happened to me so many times already that I know exactly what to do if Chinlock screams at me. Yeah. So yeah, there we go. We actually fixed that problem and we don't even use any malloc. Oh, holy shit, by the way. Yeah. The only problem here is that we still use like fprint. I'm just thinking, can we remove dependency from libc? Probably not. Probably not, because we still need to interact with files and stuff like that. It's just kind of too much work. I shouldn't focus on that. But yeah. So, by the way, at the end of the bosom, we can also print how much memory we consumed. I think that's actually a cool idea. Print f consumed LD bytes of memory, right? And we can put something like bosom memory size, and let's take a look at that. Is it memory? Oh, it's not a pointer. All right, so that's pretty cool. That's actually pretty small. They don't really take that much memory, so we don't even need to have any mallocs or anything like that. Anyone who can work in C and CPP always has my envy. Why? I could do enough to get by, but I never really understood it like I do with higher level languages. I guess you need to know a lot of specifics of how computers works, so you don't need to know that in higher level languages, I suppose. Static memory that's zero initialized isn't actually included in the binary, it just creates... Oh, okay. Thank you so much. And by the way, why are you not trusted, John? I think you were actually saying a lot of useful things. Okay, so if I... That's a good point. So we can try to conduct an experiment. What if I do something like this? And maybe... what if I put something like this? Missing initializer for data view. Okay. Alright. My computer is slow for some reason. I don't know why. Oh shit, it's still running. Oh fuck, it's actually writing that shit. Okay. You were right. You were actually right. It started to... That's why it was so slow. Holy fuck. You were right. Like, if I... Like, it's kind of scary how you just make this little change and your entire system is fucking destroyed. Like... That is so cool. Yeah, you definitely deserve a trust. Thank you so much. That's so nice. Okay. Because no, it's not because it's running Emacs, and yeah, so it basically puts it into BSS, and I suppose BSS only stores the amount of memory that will be expanded at runtime or whatnot, right? So yeah, that's why in BSS section you cannot initialize anything because, well, you cannot, it will be expanded. Well, if I understand correctly, I know nothing about how things work in runtime on assembly level. Okay, that's cool. It is in fact scary. So yeah. All right. So we have this entire stuff. How many times I even use malloc? Okay, so in BME, oh, I use a malloc in the bindings for malloc. Okay, that gives me an idea that BM. Oh yeah, we have an issue for static memory for BM, so I shouldn't think about that too much. All right, so let's continue. Are you trying to destroy my entire system? All right. Let's go back to the examples, and so here's the alloc. It seems to be working. Let's go to the bosom, and let's include examples natives Hasm. I'm not really sure if Hasm is a pretty good name for this thing. I would like to call it bosom, but that will make it automatically build as a bosom thingy, which doesn't make any sense. Okay, native, and this is print f64. Right, we're printing f64, and it seems to be working. Fib, the same situation. Okay, we already implemented everything here. It's like ham, but with S. Sure. That's a good analogy. Thank you so much. Include examples. Natives Hasm. Native. Do we have native? Is going to be print f64, and things like lerp can go in some sort of a mathematical library that you can also include. I think it's cool. I like that. All right, so natives, we already know what's going on here, and PyBasm include examples. Natives Hasm, native. Oh, and it's interesting is that this kind of shit makes the external native function declaration sort of obsolete because you can just have labels. So I don't think it's that important now. Print f. So it was 2, right? Print f64. Print the result. Cool. Holy assembly. Yes, it's holy assembly. Holy assembly. My god. Cool. We also updated this thing. So yep. Very cool. Build tool. Build the tool chain with debug info. All right. Replace malloc with a linear allocator in Basm. So that was very important. Use preprocessor in the examples. There we go. So we implemented everything we wanted. So we have a simple preprocessor that can define new labels and it can include files. We don't depend on C preprocessor, so this thing is supposed to work even on Windows. Except maybe there will be some problems with paths, right? Because slashes. Windows uses backslashes, but as far as I know, the modern Windows also understands like a forward slashes too, so it shouldn't be a problem. In any case, we have a continuous integration, so it shouldn't be that much of a problem. Alright, so I already pushed everything. How many to-dos did I introduce throughout this thing? Include directory has no support for include paths. Label redefinition does not tell where. Okay, so that's okay. And another one is second pass label resolution that don't report location. Okay, so this is separate things that we'll need to. All right, so hopefully this will build now. That was a rough feature, by the way, because we had to. Okay, so it doesn't even build on Windows anyway. Use preprocessor in examples. Okay, so it still doesn't build on Windows. I got rid of the C preprocessor, it still doesn't build on Windows, okay. Is not recognized as external or... Okay. Or LD something, okay. Oh my god. Oh, okay. Because it's a long... and what do you do in this particular case? It has to be LU. Periodic argument 1 has type CST. Consider using ZD in the form... Okay, so let's actually use ZD then. Typical C++. Yeah, boy. Let's use ZD. Okay, this seems to be still working. Consumed... not really consumed, let's actually rename it to something else. Bytes of memory used, I think it's a little bit better. So it will tell how much memory it used. It's not really that useful of information, I just wanted to print it. But yeah, I could simply remove it. For fuck's sake, I could just simply remove it. Why do I even need that? I just needed that to see if it actually works or something. Remove redundant debug logging. I don't know why I wanted to keep that. It only makes the Windows build fail. It only makes the Windows build fail. Right, hopefully it will build now. That's a lot of commits, look at that, and that's a lot of changes. It's a little bit over my limit, but not that much. Not that much. And while it's building, we can snitch up the to-dos that I introduced, so why not? Report, prepend body, introduced in 49. Path include directive has no support for include paths. There we go. Label definition, blah blah blah. Okay, so let's report all that. Cool. And let's push that right into the repo. Cool. Hello, Programador Binario. Hello. Okay. That's a huge body of work, not gonna lie, I didn't expect that. But now we have a very simple preprocessor that can do shit. Yeah, you can define new labels that you can reuse in the operands of the instructions, and you can include new files, even recursively if you want to, of course. Conditional compilation, we do not support conditional compilation. But maybe we could. Who knows? I don't know. Why not? Shouldn't be that hard. So how would you support conditional combination? So support conditional combination compilation, you will need to support expressions and shit like that. I'm not sure if it's a good idea generally. So for now we have a simple preprocessor that does its job, and yeah, we don't need anything else. And it's supposed to work seamlessly on Windows as well. Conditional compilation will add a lot of work for label dereferencing. I don't think so. Because you can just do conditional compilation in a streamlined way. So essentially you encounter conditional compilation, like if def, you check the condition. If it's true, you continue until the end of the block, until the end of the block. If it's false, you just jump over and continue translating. It doesn't really produce, because label dereferencing is postponed. That's the thing. Label dereferencing is postponed. So essentially, if we encounter an instruction that refers to some label, we do not dereference that label until the end of the whole translation. We only remember, okay, that operand refers to that label, let's remember that operand and go back to it later when we're done translated everything and when we collected all of the labels. And at the end, we have a second phase that goes through all the deferred labels and resolves them. You can even see that in the source code itself. So yeah, literally second phase, there was like here. So we literally like iterate through deferred operands, right? We get the labels that they refer, and then we resolve them. So yeah, there's literally two phases. The first one is that one, the translation phase, and the second one is deferred one. So that resolves a lot of problems. I'm telling you, like, I'm literally developing like a proper programming language at this point. It's actually amazing. I didn't expect that, but yeah. And look at that, it compiles on all of the platforms without any problems. Isn't that amazing? I think it's goddamn amazing. Compiles on Linux, macOS, FreeBSD. No, we don't have a FreeBSD build, but it also compiles on Windows. Yeah, I'm so proud of myself. And that also spawned a bunch of issues that we have to resolve, and I'm ready to fucking merge that first try. First try, mother flipper. Delete branch. Nice. Okay, so let's go back and fetch the changes that we just merged. Merge origin, master, and remove that. Alright, that was cool. What else do we have here? What are the other issues that we can work on? So separate instruction for bitwise operations. Oh yeah, so this thing is redundant, by the way. So external native function declaration for boson files. So the idea is the following. Let me find this thing. Right, is that you would be able to define these external function declarations, and then you will be able to use them like this, some native print f64. But we already have that in the form of labels. So yeah, we don't need that anymore. So this thing became invalid essentially. So the thing I need to do here is to simply remove this entire stuff. Right, so I'm gonna remove this. And I'm gonna commit this in close invalidated by and we're gonna refer to the pull request that we just closed. It was somewhere here. I once downloaded lots of free BSD, but I don't know how to mount MP4 files to virtual. What? Oh god, okay. Invalidated by 49. Invalidated by 49. And you can now just use label directive to bind native function name to its number. There we go. And let me push that right into the master, so, and it will automatically close this file, close this issue hopefully. It will automatically close the issue. There we go. So that was cool. By the way, for those who doesn't know, the source code of this virtual machine and assembly is available here. You can look into that and you can use it for free. It's completely free. So what else do we want to work on? We can work on something completely something different, right? Completely something different to actually, you know, mix things up. For example, separate instructions for bitwise operations. Does it sound interesting? So yeah, bitwise operations. Because we worked on assembly for pretty much the whole stream for 4 hours. So maybe it's time to start working on bitwise operations. And since we refactored all of this stuff, adding new instructions is super easy, actually. It's super fucking easy. Yeah, let's go ahead and do that. Code looks a lot nicer, yeah. I'm telling you, just pile garbage on top of your code until patterns emerge, and then just, you know, compress them, and look, code starts to look nicer. Just like this. Look at this nice code. Ah! Anyways, garbage driven development, yes. GDD. All right. So let's introduce some instructions. If. Excuse me, are you okay then? All right, so let's create a separate branch. Let's create a separate branch, 11. So what bitwise operations do we know? And but what's interesting is that we need to distinguish them from the logical operations, do we? Or do we not? Maybe we can just only use bitwise operations. Nah, I think we also need logical ones. I think we also need logical ones. So just in case, I'm gonna prefix them with and b, then orb. So and or zor. Do we have anything else? I don't think we have anything else. The other things we have is shift right and shift left, and that's pretty much it. And because zor like is not needed for logical because it's not equal, right? So we're not gonna have like zor b and zor b and shr and shl. They'll also always be twice. Do we need anything else? BSF. What is BSF? I don't understand. Beat scan forward. What is that? Invert. Yes. We already have not, so that means I'm gonna have not B. I guess that's it. So I cannot recall any other instructions. So yeah, let's just go ahead and introduce them. Should press it forward. Okay. So the cool thing about these instructions is that none of them have any operands, so we don't have to worry about that. Case. Return 0. Right, none of them have any operands because they operate on a stack, right? Can I do something like this? So if I do a line... Oh shit, it didn't work. Should have actually done that slightly differently. There we go, now we're talking. So yeah. Okay, so this is native and B, not B. Yep, so what's gonna be the next thing? Now we need to specify their names. Right, what are gonna be their names? That's a good question. That's a good question. I think the easiest way to make their names. What am I making? I'm making a virtual machine. Check out the today command. Boom. So that should be it, almost, because we also need to specify their behavior. Right, we need to specify their behavior. So let's go here. And this is going to be a case. Might as well actually do something like that. Then go down here and break. Cool. Yeah. This one is interesting. Not even a real machine. Okay, good. So the thing I want to do, I want to also do something like assert to do. Right. Instruction is not implemented. Cool. Yep. So is it gonna compile? All right. So we want to try to implement an example that would use these things. Is this way I'm gonna support JIT? Yes, it will. Okay. So let's implement gray code generator. You guys know what is a gray code? Gray code. KW. Gray key OD. So basically, it's the enumeration system that differs, where each consequent number differs from the previous one with 1 bit, and we can try to implement that. So let's go and implement that. So it's gonna be gray bosom. Yes, I know now, but there may be people who are new to this channel, so yeah. What about AOT? To be fair, maybe my answer was not correct. We have an issue for the following thing. Let me show you. Yeah, BM bytecode translator to x86-64 native code. So we have that. First thing we're gonna do, we're gonna implement a translator that takes BM bytecode and translate it to native code. The difference between AOT and JIT is in the last letter. Ahead of time, just in time. So basically the only difference, once you have a translator, the only difference between AOT and JIT is when you call that goddamn translator. You see what I mean? So whether it's JIT or AOT doesn't fucking matter if you don't have a translator. Like once you have a translator, it's the only difference just when you fucking call that translator. So, yep. That's why I didn't mention any JIT or AOT in this issue, so the issue is related to that. Does it make sense? Makes sense? Hopefully makes sense. Alrighty, so let's try to implement the Gray code generator. So 1, 2, 3, 4, GMP main, and it's gonna be something like that. And how we're gonna generate all of that? So it should be pretty straightforward. So why would you use a JIT then? It's a good question. So essentially, I think I'm not actually an expert in JIT compilers and virtual machines and stuff like that. Ironically, ironic, am I right? So I'm really not an expert in everything that I do here. But I would imagine that AOT could slow down the startup time. And in case of a JIT, you only compile what's needed just in time. So basically how JIT works, at least in JVM, as far as I know, is that they measure so-called hotspots. Hotspots, basically the segment of code that is executed the most, and they compile only that segment of code without wasting time on compiling something that is used rarely. So you see what I mean? Because doing the compilation, right, also takes time and effort, so you don't want to do that very often, especially if your translator and compiler is very powerful and it can apply many optimizations. So it can actually do that very slowly, right, because it needs to do a lot of analysis and stuff like that, so you don't want to trigger it on the whole program all the time. Plus, your program can be dynamic and stuff like that, so some of the code may not be known ahead of time. You see, so that's the difference between AOT and JIT. So speaking of like, why do you need JIT? You need JIT for these kind of reasons. Does it make sense? But again, take everything I said with a grain of salt, because I'm not an expert in virtual machines. But some time ago, I think like around 10 years ago, I worked as an intern in Intel, and I spoke with like actual people who work on JIT compilation in virtual machines, like professionally. And so this is pretty much what I heard from them. So, but again, I'm not an expert in this kind of shit. So, anyway. Gray code. Right, gray code generation. So we're gonna start with just pushing 0. And this is gonna be our counter, right? This is gonna be our counter. Okay, comrade, our counter. So this is gonna be n. Maybe I'm gonna call it I. But we also need to keep track of n, right? So it's have to be, yeah. But the cool thing is that I can now define label n, and I can include examples natives, native hasm, right? Natives hasm, and let's say we want to generate like 31st numbers of the gray code. Now, so when I push I on top of it, everything looks okay. Then I think I need to start duplicating it. But I forgot how to do the gray code. Let me take a look at the Bezier curve example that we did recently. So I'm gonna look into the vertex shader. Oh yeah, so it's basically X, XOR, shift to the right. Okay. So what we can do here, we essentially can try to do dupe 0. So this is going to be loop. Dupe 0, that will duplicate this thing. That will duplicate this thing. Then I think I need to do another dupe to have like 3 of these things here. Right. And I want to shift to the right the top one, right? So I'm gonna push 1, right? It's gonna be 1, and then I'm gonna do SHR. I'm gonna do SHR, which will result in this, right? Which will result in this, and then I want to do XOR, which will result in this, and then I'm gonna do a native print U64, which will consume this. And there we go. We're gonna end up with I. So we generated one gray code number, right? Then I wanna duplicate I, push 1 and plus I. So that will essentially add 1, then sum it up, right? And then we need to repeat all of that. So we need to repeat all of that. It's going to be GMP, a loop. But at some point we also need to stop. So that means it has to be if, but we need to put some sort of a condition here. So what I'm going to do here, I'm going to push n, right? And I'm going to check if it's equal, if they're equal to each other, and actually not equal to each other. If they're not equal to each other, only then I'm gonna jump forward into the loop. So we're gonna keep incremented I, and there we go. We just implemented the gray code generator. Yeah. So and this is the amount of iterations. Does it make sense? Does it make sense? That's actually pretty cool. So I really like. I'm getting good at programming this machine as we implement more and more useful functions and functionality. It just becomes really pleasant to work with that machine. I really like that. And adding new instruction is super easy now, so like assembly automatically picks it up. That's pretty cool. All right, so, and it compiled. Look at that, it automatically compiled it. And if I try to debosom this thing, and gray bosom, and it's actually has to be BM. There we go. So everything is sorted here. As far as I know, Java is compiled to JVM bytecode ahead of the time. Then the bytecode is interpreted and JITed if it's called multiple times. Hotspot .NET is compiled ahead of time to bytecode and only JITed but never interpreted. The line between JIT and AOT is kind of blurred depending on implementation. The line between JIT and AOT is in the last letter. I already said that. The line between them is in the last letter. But it's still blurred, don't get me wrong, I do agree with you, it's still blurred. What am I working on? I'm working on a virtual machine. Time, yes, time. How much time? We're already streaming for 4 hours, holy fuck. Okay, so we have this thing, and we can try to interpret it. BME, and there we go. SHR instruction is not implemented. All right, so let's go ahead and implement it then. So BMH, it's almost like implementing like a NES emulator or something like that, right? So you basically take all of the Yeah, you essentially write an emulator, and every time you encounter a known instruction, you just crash. You take a game, you run the game on your emulator, and every time you see a crashing instruction, you go to the manual, implement an instruction, and repeat that until you have a full emulator. So we're kind of doing the similar thing here. Zozin, why not implement it? Because I don't know how to do that. Okay, SHR expects 2 operands, right? It expects 2 operands. So what we can do here is check the size of the stack. So it's going to be stack size. If it's less than 2, right? If it's less than 2, well, this is a stack underflow. This is a stack underflow. Error stack underflow. There we go. So after that, what we need to do, we need to take stack size -2. So we're gonna actually, yeah, we're gonna do the following thing where I just take the previous frame and I do SHR of the top frame. Right, I do SHR of the top frame, right, and that consumes the top frame. So that means the next thing I have to do, I have to do stack size -1. And there you go, we just implemented the SHR instruction. That's how simple it is. Tired D developer. Nice one. So it's literally Hertz and plots. Tired D developer. Okay, so what do we have here? Invalid operands. Okay, we're gonna interpret this entire stuff as U64. Yeah, as U64. Why are you guys laughing? Did you predict that I'm gonna make this mistake or what's? Alright. So okay. Stack underflow. The fuck? Did I have to? Why does it still work? It doesn't have to do stack underflow. That doesn't make any fucking sense because I still need to have like ZOR and okay, let me try to debuzz this thing and SHR. And why don't you try to do ZOR? That doesn't make any fucking sense, mate. I implemented SHR. Right, SHR, I implemented it. Because after that, you should not forget to do IP+1. Yeah, because it was keep repeating the same operation, and okay, I see now. That makes sense. Okay, so now ZOR instruction is not implemented. Let's go ahead and implement it. Should be pretty straightforward as well. It's pretty much the same thing here, right? So here's the ZOR instruction, but instead of this thing, we're gonna do a ZOR. Cool. Is it gonna work? Hey, Sodding, have you tried Zeek++? You should try it, please, please, please. Well, if Zeek is $300, Zeek++ is probably gonna be even more expensive. Yeah. Okay, so if we try to interpret this shit, it's never actually stopped. Holy fuck. Why are you not stopping? So I think I fucked up a condition somewhere. I definitely fucked up a condition somewhere. Let's give it a try. Alright, so we push an I on top of the stack. Then we duplicating it 1 time, 2 times. Then we push in 1 on top of the stack and we do SHR, producing this shit. Then we do ZOR, producing this shit. Right, there we go. And then we do print U64, consuming this shit. Then I'm duplicating. I actually don't need to duplicate it. That's the problem. Okay, so then I push 1 and then I add everything up. So it produces this thing. Then I push 30 and check if it's equal. So yeah, that's the problem, I think. So before pushing 30, what you have to do, you have to duplicate 0, making a copy of it, and then push n, rather, not 30, but n. And then check if they're equal, and then you'll get a consumable boolean that can be consumed by jump, and you're gonna end up with this thing. Okay, so I think I fixed the problem now. I'm really getting good at this assembly. Holy fuck, I really like that. There we go, so we have a gray code. So let's actually check if it is in fact the gray code. So how are we gonna do that? So I'm gonna copy paste this entire thing to here. So we have a database of all the numbers. Database of number sequences. What is a gray code? It's this thing. Check it out here. It's just a sequence of numbers in a very specific order. The idea is that the difference between... Oh, чистый код. I don't see any... Oh, here we go. 5 months.
5 months POC.
5 months POC. Thank you so much for 5 months of tier 1 subscription, and welcome to our epic Gray Code Club. How about that? Epic got Gray Coders. Anyway, so basically the idea is that the difference between two consequent numbers in a gray code sequence is only 1 bit in their binary representation. So if you take any two numbers here, for example 8 and 9, the difference between them is 1 bit always. No matter what the pair of numbers are, consequent ones, it's always going to be 1 bit. So yeah, that's what it is. And where's the database of all the numbers? Yeah, this one. OEIS, and I'm gonna just take this sequence and I'm gonna put it there. I think I also have to separate it with commas, so let's put it like that. And I'm gonna just put it here. And is it a gray code? Yes, it's gray code. We just generated a gray code with Basm. Isn't that amazing? I think it's goddamn fucking amazing. But that does not utilize all of the bit operations. All the bit operations. We can actually try to generate like thousands of them. I think it's not that hard to do. Yeah, here's the thousands of them. What about 10,000s? Yeah, it was actually pretty fast. What about million? I think we can also do that. I can also redirect all of that to def null, right, to remove the IO from the equation. And yeah, if you take a look at the time, so our virtual machine is capable of calculating 1 million gray code numbers in half of a second. I don't know why it would be important, but you can do that. It just does that. What about 10 millions? Yeah, it's pretty cool. I would assume it's gonna be 5 seconds because it's linear. It should be 5 seconds. Yeah, it was 5 seconds. Like, I mean, you just multiply the n by 10, and what did you expect? It's a linear algorithm. It's gonna be 5 seconds. I mean, anyway. So let's actually make like 100. Yeah, and boom, there we go. It's pretty fast. So what we did here is introduce gray example. It's going to be 11. Implement gray code generator example. All right, so let's take a look at the other instructions that we have not implemented yet. So what can be the other instructions? We still have a lot of them. And or SHL not. The question is, what can we implement there? What we can implement there? That's a good question. So does anyone know any interesting ideas what to implement with all of them? MD5 hashing. No, something simple. Something simple. That will involve some of them. Maybe some other sequences, some other interesting sequences. So maybe, oh my god, there's a lot of Print bits of numbers. That's a good idea, actually. I like it. Let's actually print bits of numbers. Alright. So, yeah. Maybe we should start documenting these things. Generate n gray n numbers from the n gray code numbers. So, and we can refer to this thing. Print bits of a number. BM can't get input yet. You can actually write a native function that reads a number from a user. I don't know. All right, generate the other stuff. Bits, Basm. Print bits of number n, right? And we're gonna include example natives. Native hasm. Okay. Native hasm, and we're gonna have a label n. What's gonna be the number? Does anyone know interesting numbers that? Let's put 255. I think that will be okay. I think that will be okay. So and we're gonna start with the following thing. GMP 69420. Okay, sure. Let's do it this way. Main, and then we're gonna halt. Then we're gonna halt. Okay, so we're gonna push that number on the stack. So we're pushing it on the stack. This is what we have on the stack. Cool. Bits the number. So we're also gonna have a loop. Right? And what do we need to do here? We need to extract one bit. So that means first thing I need to do, I need to duplicate this n, right? And push 1 on the stack. Right, I want to push 1 on the stack. Then I need to do AND B to extract one bit from this thingy. To extract one bit from this thingy. Once I extracted that one bit, I need to print it. So I'm going to do native print U64, and that consumes that bit. Right, that consumes that bit. Afterwards, I need to shift to the right. So that means I already have a shift right, so that only implements AND B. But I mean, it's still good. So I'm going to push 1. Right, I'm going to push 1. Then I'm going to do AND B. No. Shift right. Right, it's going to be shift right, and there you go. Afterwards, I need to duplicate it just to see if it's equal to 0. So I'm duplicating it, then I push 0, like that, 0. Then I check if they're equal. So here, we're going to have something like this. Yeah, if they're equal. So here we're gonna have a boolean, and then I'm gonna do jump if, which will consume this boolean, and if it's true, it's gonna jump to the loop. There we go. So here's the whole algorithm. Holy shit, I'm getting really good at it. It's actually, once you get used to it, it's super easy. Holy fuck. And we don't even have any registers or anything like that. This is so useful. Holy shit. Like, at first it was kind of difficult to program this assembly, but once you get used to it, it's just actually not that difficult. And it's super fun. Registers are harder than stack, yeah. Registers are harder than stack. Okay. Alrighty, so is it gonna compile? Okay, so do we have bits? Yeah, here they are. So if I disassemble the bits, bits bm, so we do have everything here, and if I try to do this thing, there we go, instruction and b is not implemented, so let's go ahead and implement it. And b, so it should be pretty straightforward, right? So I'm gonna just copy paste this thing here. So the only difference is that we're gonna just use and. Okay. Alright. And it was 0. Nice. It literally did nothing. I wonder why. Okay, where did I fuck up? Where did I fuck up? So then we duplicate it one more time. You forget not. Oh shit, yes, not. Thank you so much. And boom, so here are the bits. Are these the bits? 69 for 20. 0 0 1 1 0 1. I think they are. If we can try to, confirm that. So they are in a reversed order though, right? So they are in a reversed order. So if I just connect them together and then query replace. Wait a second. I can actually do that slightly differently. I can reverse a region, right? Then connect everything together. Then query replace spaces with nothing. And if I copy paste the result from Python and align everything, there we go. We did it. Look at that. We did it. So our program successfully extracted the bits from a number. It's pretty cool, I think. I think it's kind of cool. Not gonna lie. All right. So So in the bits, do we have anything? Example bits bosom. So print bits of number, and you can modify number however you want. You can modify number however you want. Alrighty. This could be a pretty cool like educational machine. Yeah. Implement bits example. Let's push that right into the repo. Okay, so what are the things we have not implemented yet? Or shift left, not B. Okay, so what could be the other things? So we still need to implement or shift left and not. So does anyone know any interesting examples? NAND boxing? Should we implement NAND boxing in the virtual machine itself? That's actually an interesting idea. Just implement NAND boxing. But it's too hard to implement, right? Well, maybe it's not, to think about it. So I actually need to do OR. Where can I use OR? Boxing with S none. Okay, whatever. I'm gonna just go ahead and implement them, and I think we have enough examples. But having NAND boxing as an example would be actually kind of cool. So we were trying to make NAND boxing a part of the virtual machine, but now you can just implement it in virtual machine assembly. I think it's kind of cool. Not B. And not B is actually slightly different because it only accepts one argument. So it's... yeah, it needs to be like this. It doesn't reduce the stack, right? doesn't reduce the stack, and it only operates on the first thingy here, and that's essentially what it's doing, right? So just inverts the bits, Do we have any other to-dos? I mean, not reported ones. Okay, I think it looks good. Cool. Now, yeah. Implement the rest of the bit operations. Let's push that right into the ribbon. That's cool. And it's gonna be a pull request. We're ready to submit the pull request to the project. Okay, so implement bit operations, bit instructions, bitwise instructions, close 11. All right, so that was cool. And you can find the source code of this thing that we implemented here if you're interested, of course. So the entire virtual machine is completely open source, and we're developing it on the stream, and it's under MIT. Feel free to do whatever the fuck you want with it. And as you can see, we have a lot of examples on the virtual machine assembly and how to use the assembly and stuff like that. Yeah, we actually introduced more of these things, but yeah. For example, I like Pi example. I think it's cool. Anyway, I think today's stream was really productive. But unfortunately it's been almost 5 hours. And it's time for me to go, boys and girls. It's time for me to go. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all tomorrow. Tomorrow we're gonna continue developing this thing. By the way, yes, we're gonna keep developing it for the 3 days until Thursday, and on Thursday we're gonna do Advent of Code 2019, right? So on Thursday we're doing competitive programming stuff. So yeah, tomorrow we're gonna continue doing this thing. Check out our schedule. I haven't updated schedule yet, so it will tell you that we're gonna do something else, but I'm gonna update it. We're gonna do a virtual machine tomorrow. Check out our VODs channel where we archive all of our streams. This stream is gonna be there, but tomorrow we upload them on the next day. We have a special playlist where I collect all of the virtual machine streams. If you wanna watch the development of the virtual machine since the beginning, you can find that playlist there. So there's literally first day where we started this virtual machine from scratch, from an empty file, and we evolved it into this system, which is pretty goddamn cool. And also check out our Discord server for offline discussion with the community. So, and yeah, boys and girls, that's it for today. See you all tomorrow. Love you all. Mwah.